Hi guys, welcome to my channel. In this video, I will be covering complete DevOps subject. I will explain all these 5 units. I will explain each and every topic in detail. And whatever the topics that I am going to cover in this video, I will provide all those topics and the timings in description. Before starting this video, please check in description. I will provide complete DevOps handwritten notes in description. You can download from description. If you are watching this video for the first time, don't forget to like, share and subscribe to my channel. Let's get started. At first, I will start Unit 1. I will explain each and every topic in detail. At first, I will explain what is software development lifecycle. Guys, we also call this software development lifecycle as software development process. Process is nothing but sequence of steps followed by software company in order to develop high quality software is known as process. So, software development lifecycle is a process used by software industry or software companies in order to design, develop and test high quality softwares. The main aim of software development lifecycle is to produce high quality software. The software must reach customer expectations and the software must complete within short time with less cost. If you want to develop any high quality software, then without using any software development lifecycle, you cannot develop high quality software. For example, whenever any team is developing software, then they must clearly understand what to do and when to do. If they don't know what to do and when to do, then they cannot develop high quality software and their project may get failure. So software development lifecycle contains complete steps from starting to till the end. And these steps are in disciplined and systematic manner. So by following these steps, we can easily develop high quality software. This is complete software development lifecycle. By following this process, that is by following these steps, we can develop high quality software. This first step is requirement gathering and analysis, and next step is design, and after that implementation or coding, and next step is testing, next deployment and maintenance. I will explain all these steps one by one in detail. First one is requirement gathering and analysis. Guys, in each and every software company, there will be a business analyst or project manager. What they will do is, they will communicate with clients. Clients are nothing but people who want software. They are clients. For example, I am college owner. I want one college application. So here I act as client. So I'll go to software company and then I will meet this business analyst or project manager. And then I will ask them to create one good quality software for my college. And then I will tell about my requirements like my college software must contain both login forms for student and faculty. And the software must display attendance of student and faculty. And then the software must display marks of students. And it should display complete faculty details and so on. So I'll tell all my requirements to this business analyst. Whenever I tell my requirements, this business analyst will note my requirements in one document. The document name is Business Requirement Specification Document. So after finalizing this Business Requirement Specification Document, they will create another document. The document name is Software Requirement Specification Document. Shortly we call it as SRS. This SRS document contains complete information about project like what are the softwares required to develop this project and what are hardware requirements, like how much time it will take to complete this project, how many developers required, cost of the project and so on. So they will mention all this in SRS document. In requirement gathering and analysis phase, they will create BRS document, they will create SRS document. This is all about requirement gathering and analysis phase. Next one is design phase. After completion of requirement gathering and analysis phase, in software company, designers will create one blueprint. Blueprint is nothing but diagram. So by seeing that blueprint, we can clearly understand that how our software look like after implementation. For example, if you consider house construction, before constructing house, builder will show you one blueprint. So by seeing that blueprint, you can clearly understand that how our house will look like after construction. So in same way, before actually creating any software, designers will create one blueprint. By seeing that blueprint, we can clearly understand how our software look like after implementation. This design phase contains two steps. They are high level design and low level design. High level design means it will display complete software architecture. And whereas low level design will describe how each and every feature should work in the software. For example, in college software, there is login form. So login form is considered as one feature. Student login form is considered as one feature. Faculty login form is considered as another feature. And student attendance is considered as one feature. Like that, it will describe how each feature should work. Third phase is implementation or coding phase. By seeing blueprint, software developers will start developing code. This is one of the longest phase in software development lifecycle. It will consume lot of time to develop code. This phase contains front end, middleware and backend. where front end is nothing but by using which programming language they are developing code, like Java, C++, Python, so on. And backend is nothing but which database they are using, like Oracle, MySQL, and so on. And whereas middleware is software that will connect this both front end and back end. This is all about implementation or coding phase. And fourth phase is testing phase. In testing phase, software testers will take code from software developers and then they will start testing that code, whether that code is working correctly or not. And fifth phase is deployment phase. Once after successfully completion of testing, deployment engineer will place that software in one server, so all users can access the software. This is deployment phase. And last one is maintenance phase. Even after successfully releasing our software, we need to provide support. That is, if there are any bugs, we need to fix that bugs. And if you want any updates, we can provide updates. So this comes under maintenance phase. Next, I'll explain what is waterfall model. This waterfall model is one of the easiest and traditional model. And this waterfall model is suitable only for small size projects. It is not suitable for large size projects. And these are various stages in waterfall model. Same stages I already explained before in software development lifecycle. Guys, in waterfall model, only after completion of first phase, we will go to next phase. For example, only after completion of requirement gathering, we will go to design phase. Similarly, after design phase, development phase, after the testing phase, and next deployment phase and maintenance phase. So in waterfall model, only after completion of first phase, we will go to next phase. For example, I am in testing phase and I want to perform some changes in development phase. If you are in testing phase, we cannot go back to this development phase. For example, I am in development phase. Now I want to perform some changes in design phase. So if you are in development phase, we cannot go back to this design phase. If you see these arrow marks, all these are flowing only downward direction, like waterfall. So that is why we call it as waterfall model. It will only flow in downward direction. The waterfall model is universally accepted software development lifecycle model. In this method, the whole process of software development is divided into various phases. I already said before. The development in the waterfall model is seen as flowing steadily downward like a waterfall, as it is a continuous software development model. Guys, these are some of the important points that you need to remember in this waterfall model. And the first point is, waterfall model is not suitable to develop large scale projects. It is suitable only for small size projects. And next one is, the requirements in the waterfall model should be clear cut at the beginning time. You need to give all requirements of the project at the beginning. We cannot add any requirements in the middle. So you need to give all requirements at the beginning. If you don't give requirements at the beginning, we cannot develop efficient software. In the waterfall model, it is hard to move back in order to make changes in the previous phase. We cannot go back to previous phase in order to make any changes. The testing process in waterfall model starts after completion of development. So we can find lot of bugs in testing phase. This is all about waterfall model. Next, I'll explain what is use of agile model. Agile is an iterative and incremental approach. Iterative is nothing but repeating same process again and again. That is, repeating requirement gathering, designing, coding, testing again and again. This is iterative approach. Incremental approach is nothing but initially we will create one software with very basic features and then we will keep on adding new features to the same software. This is incremental approach. I will give an example. Yes, for example, I am college owner. I want to create one college software by using this waterfall model, not agile model, waterfall model. So initially in requirement gathering phase, I said features like I want college software. The software must contain student login and as well as faculty login. And the software must contain student attendance details. So the software company developed that software by using waterfall model. So after software development, again I said that I want new feature like it should display result of the student. So after creating software, it is impossible to add new features. We cannot perform any major changes to that particular software using waterfall model. In order to overcome this problem, many software companies are using agile model. In agile model, they will create software with very basic features. For example, I said I want student login form in that software and I want faculty login form in that software and I want student attendance details in the software. So in the software, student login and faculty login is very important. So in agile model, initially they will develop software with very basic features and they will keep on adding new features. For example, they created student login form and as well as faculty login form and as well as student attendance details. So again I said that I want to display student results in this particular software. So easily they can add new features to that particular software. This is major difference between waterfall model and agile model. So agile model is an iterative and incremental approach. Iterative is nothing but whenever we get any new feature, we need to repeat the steps. And whereas incremental approach is nothing but initially we will create software with very basic features and then we will keep on adding new features to that same software. So this is diagram. It will run like a loop. For example, for first feature, it will plan, design, develop, test, deploy, review, and then it will launch. And similarly again for new features, again plan, design, develop, test, deploy, review, and launch. So this is iterative process. In agile process, we will deliver piece of software with few functionalities and later on we will keep on adding new functionalities to that same software. So there is no need of customer to wait long time until entire software is developed. So there is no need of customers to develop long time until entire software is developed. Agile is a process that follows concept of Agile Manifesto held in February 2001. Guys, this Agile Manifesto is nothing but it is a book that contains 12 principles. Software companies must follow these 12 principles in order to develop high quality software. And the first principle is highest priority is to satisfy the customer through early and continuously delivery of valuable software. In this Agile Manifesto, first principle is to satisfy customers. How we can satisfy any customer? We should deliver software very fast and then we need to add new features continuously to that same software. And next principle is allows customers to change requirements even late in development. For example, first time I said only I want student login form. This time I said that I want both student login form and as well as faculty login form. So this agile model allows customers to change requirements. And third principle is deliver working software frequently within a short period of time, that is from couple of weeks to couple of months. Guys, within short period of time, that is maximum within 2 to 4 weeks we need to deliver software. And fourth principle is business people, developers and testers must work togetherly daily throughout the project. So these people must communicate each other daily so they can deliver software within very short time. The agile principle is about to having faith in your team and helping them to do their best work. It's like giving them tools and encouraging them to success instead of continuously watching over their shoulders. Guys, in this agile model, product manager will not force employees. He will give freedom to work. So that is why developers and testers can easily work and they can complete software within time. And sixth principle is face-to-face conversation with your team. All employees like business people, developers, testers, they will conduct face-to-face meetings. And seventh principle is working software is the primary measure. They must deliver working software. And eighth feature is agile process promote sustainable development. That is nothing but continuous development. And ninth one is technical excellence. Development team must work continuously and they must deliver high quality software and the software must reach customer expectations. 10th one is simplicity. Simplicity is nothing but they must focus only on important tasks and they must avoid unnecessary work so they can achieve their goals faster. And 11th one is self-organizing team. Here in agile model, manager will not guide you. Team members must communicate each other and they must complete their work. And last 12th principle is adjustments. Immediately whenever customer give any changes, immediately company must adjust their plan based on that particular information. For example, immediately customer said that he want to add staff information in that particular page. Immediately company must perform that work. These are 12 principles in Agile Manifesto. These are 12 principles in Agile Manifesto. Guys, all these principles are advantages. And these are disadvantages in Agile model. First disadvantage is less documentation. Whereas if you consider waterfall model, they will do complete documentation. But whereas in agile model, documentation is very less. And next disadvantage is team must be knowledgeable. Whenever customer give any new feature, then team must immediately update that new feature in that existing software. So if team members don't have any knowledge, it is impossible to develop software. And next disadvantage is the project can easily get taken off track if customer is not satisfied. After developing complete software, if customer is not satisfied, then they need to start work from the beginning because customer satisfaction is highest priority in agile model. So if customer don't like the software, company will simply throw out the software. Next I will explain what is Scrum methodology and Kanban methodology. And also I will explain difference between Scrum methodology and Kanban methodology. Guys, we can implement agile process by using 4 methodologies. They are, first one is extreme programming. Shortly we call it as XP. Second one is future driven development. Shortly we call it as FDD. Third one is Kanban and fourth one is Scrum. Normally by using these 4 methodologies, we can implement agile process. But mainly most of the software companies use only these 2 methodologies. They are Kanban and Scrum methodologies. So in this video, I will explain what is Kanban methodology and Scrum methodology. At first, I will explain what is Scrum methodology. Agile is basically a process model, whereas Scrum is a kind of framework through which we will develop, test and release software. Guys, as we know, agile is nothing but agile is a process. Process is nothing but sequence of steps that we need to follow in order to develop any software. Whereas framework will provide you guidance and tools in order to complete process. In simple terms, agile process will say you what to do, whereas Scrum framework will tell you how to do it. So agile process will say you what to do, and whereas Scrum framework will say you how to do it. So agile contains principles. That principles will tell you how process must be. And whereas Scrum is a framework that follows agile principles. As we know, these are various steps in agile process. So agile process will tell you by following these steps we can develop any particular software. But how to complete this process, that is how to plan, how to design, how to develop, how to test, what are tools and techniques that we need to use, all this guidance will be provided by Scrum framework. So Scrum is a framework through which we will build software product by following agile principles. This Scrum framework will follow agile principles. Guys, before explaining this Scrum topic, you need to know what is epic and what is story. Guys, for example, I am college owner. I'll go to software company and then I will tell product manager, I want one college software. This is considered as epic. So epic is a description of what client wants, or you can also say it as what client needs. I just said that I want college software, but I did not say that how college software must be. So I'm not telling any functionalities. Just I said that I want college software. So epic is a description of what client wants or client needs with less functionalities or no functionality details. It will not provide any functionalities. So epic is nothing but epic is a big work. So this big work can be divided into smaller user stories. Each story will describe one feature. So story is nothing but, so user stories are simple and short descriptions of a feature told by customers or users for his product. For example, I am user or customer. I said that I want college website. So this college website is considered as epic. And again I said that in that college website I want student login form, faculty login form, student attendance, faculty attendance, student marks, student results and so on. Student login form is one feature, faculty login is one feature, student attendance is one feature, faculty attendance is one feature, faculty details is one feature and so on. So each feature is considered as story. So epic is a big work and this big work can be divided into smaller stories. So basically we consider each feature as one story. So now you know what is epic and what is story. Guys, in software companies they don't call description or features. They will call epic and stories. So that is why you need to remember these terminologies. For example, software company want to develop one software by using Scrum methodology. So that Scrum team must contain these employees. They are product owner, Scrum master, software developers and software testers. So approximately this team contains 5 to 9 members. This is complete Scrum team. Now I will explain what is role of this product owner, Scrum master, developers and testers in detail. At first I will explain what is role of this product owner. Product owner is the person who always contact to customer and collect the features of the product from customer, and he will arrange all those features based on priority or importance. And finally he will accept or reject work results. If customer is satisfied with product, then product owner will accept work done. If customer is not satisfied, then he will reject work done by developers and testers. Guys, in Scrum team, what product owner will do is, product owner will meet customers. For example, I am college owner, I want college software. So this product owner will come to me and then he will collect features of my product. For example, in the software I said that I want student login form, employee login form, student attendance and so on. So student login form is considered as one feature, employee login form is considered as another feature, student marks is considered as another feature, employee attendance and student attendance is considered as another feature. So product owner, after collecting all features from customers, he will arrange all features based on priority or based on importance. For example, if you consider college software, in that college software, student login is one of the important feature. So after student login, faculty login is another important feature. So he will arrange all features based on priority. Guys, we call these features as stories. So stories which has highest priority is arranged at first, and stories which has least priority is arranged at last. And this product owner will place all these features in this product backlog. So product backlog contains list of user stories prepared by product owner. So this is role and responsibility of product owner. Product owner will interact with customers and then he will collect the features of particular software and he will arrange all those features in product backlog based on priority. So we call these features as stories. Next section, what is role of Scrum Master? Guys, the main role of Scrum Master is to handle entire agile process. He will take care of entire process from starting to till delivery of the project. He will completely look at how development of software is going on and he will establish team communication and remove blockers. And all meetings are organized by Scrum Master. Scrum Master will conduct daily meetings. Either it can be offline meeting or online meeting. In that Scrum meeting, he will join all employees like developers, testers, and then he will ask employees that what you did yesterday and what you will do today. By conducting daily meetings, Scrum Master can easily identify how work is going on and he can easily track how team is working. He can handle entire agile process by conducting daily meetings. And third type of employees are developers. As we know, developers will write code. And fourth one is QA team. That is nothing but testing team. Testing team will test code which is written by developers. These are four types of employees involved in Scrum team. Guys, now I will explain how entire Scrum process will work. Guys, we can also call customers as users or stakeholders. Product owner will collect features of the product from customers and then he will place that features or stories in product backlog based on priority. And from product backlog, stories which has highest priority is placed in sprint backlog for development. For example, if you consider college software, in that college software, student login has highest priority, for example. So product owner will place the story in sprint backlog. Whenever product owner places the story in sprint backlog, developer will start developing code for that particular story. Guys, normally there are 5 to 10 employees involved in Scrum team. As I already said before, in this development process, there will be Scrum Master. What he will do is, he will conduct meetings on daily basis. Every day he will conduct meetings. We call that meeting as daily Scrum meeting. In that Scrum meeting, all team members are involved, including developers and testers. And then Scrum Master will ask the team members that what you did yesterday and what you will do today. And also he can easily understand how development process is going on. Guys, normally in order to develop one user story, it will take approximately 1 to 4 weeks of time. And we call this time as sprint. So time taken to complete each story is known as sprint. For example, initially for college software, at first they need to design student login form. So student login form is considered as one story and time given to complete this user story is approximately 1 to 4 weeks. So we call it as one sprint. So immediately after completion of each sprint, they will conduct a sprint retrospective meeting. Sprint retrospective meeting is nothing but meeting which is conducted after completion of each sprint. In this retrospective meeting, all team members are involved, including product owner. In this meeting, they will discuss what went wrong and what went correct. Is there any improvement further? How to improve future? They will discuss all these topics in this meeting. And after that, they will conduct a sprint review. They will show that particular story to user. If customer likes that story, Scrum Master will accept. If customer don't like that story, simply Scrum Master will reject work done by developers and testers. So again, they need to start that story from first. So again, after user accepting this, again they will take new story and they will keep on updating the same software. So in Scrum method, initially they will develop software with very basic features and then they will keep on updating the same software with new features. So this Scrum method will follow agile process. Guys, these are new terminologies that we used in this Scrum method. They are epic, story, product backlog. Product backlog contain user stories. And next is sprint. Sprint is nothing but time taken to complete each user story is known as sprint. User stories which has highest priority is placed in sprint backlog for development. And next is Scrum meeting. Scrum meeting is conducted by Scrum Master every day and he will ask what you did yesterday and what you will do today. And next terminology is sprint retrospective meeting. After completion of each sprint, they will conduct a sprint retrospective meeting. In that meeting, all members are involved, including Scrum Master and product owner. In that meeting, they will discuss what went wrong, what went well, and any improvements further in upcoming sprint. They will discuss everything. This is all about Scrum methodology. Next, I will explain what is Kanban methodology. Kanban is also one of the methodology that follow agile process. Kanban framework is also based on one of the philosophy, that is continuous improvement. That is, we need to develop software with very basic features and then we need to keep on updating the same software with new features. So this Kanban framework is based on the philosophy, that is continuous improvement, where work items are pulled from a product backlog into a steady flow of work. Guys, this is how Kanban methodology will work. Initially in Kanban methodology, complete work is divided in the form of cards. This Kanban board contains 3 columns. They are to do, doing and done. Initially some cards are taken and then they are placed in to do column. That is, work is not yet started. Software developers must pick these cards and then they must write code. Whenever software developers are writing code for that particular card, they are in doing state. After completely development and testing, cards are placed in done stage. So Kanban board contains 3 stages. They are to do stage, doing stage and done stage. As entire work of software is divided in the form of cards, only some cards are placed in to do stage. They will not place complete cards in to-do stage. Initially, they will pick only few cards. In many of the companies, limited card number is only 3. Initially, they will take first 3 cards and then they will complete work. And again after that, they will take another cards. This is how they complete project by using Kanban methodology. So this Kanban methodology is one of the popular methodology after Scrum methodology. Kanban board is a form of visual project management. In a Kanban board, tasks are represented as cards and move through stages of work represented as columns. Each stage is represented as columns. This Kanban method was developed by Taichi Ono. He is a Toyota engineer from Japan. He developed this method in late 1940s in order to improve Toyota production system. Basically, Toyota is car company. These are some of the principles in Kanban methodology. And the first one is visualize the work. As Kanban board is visual representation, by seeing Kanban board, we can easily understand how much work is done. And next principle is limited work in progress. As I already said before, they will place only few cards on Kanban board. They will place only few cards on Kanban board. And third principle is manage workflow. Main focus is continuously flow of work. That is, initially they will take some cards and then they will perform development and testing, and immediately after that they will take another cards and they will perform development and testing. So this process flow on. And fourth principle is implement feedback loops. In this, team will conduct feedbacks, they will identify issues and solve a problem. And last principle is improvement. Initially they need to develop software with very basic features and then they need to keep on updating same software with new features. Okay, these are differences between Scrum and Kanban. In Scrum, work is divided in the form of sprint, whereas in Kanban, work is visualized on Kanban board. In Scrum, how to complete software. This planning is done before each sprint, and for each sprint there is fixed time, that is 1 to 4 weeks. And whereas in Kanban there is no fixed time. For example, one card is completed in 1 day. Immediately they need to take next card and they need to keep on working. And third one is, in Scrum there is product backlog. In this product backlog, all user stories are arranged based on priority. Whereas in Kanban, there is no fixed backlog. Whenever Kanban board is free, items are taken from product backlog and then they are placed on Kanban board. In Scrum, daily meetings are conducted by Scrum Master. But whereas in Kanban, there are rare meetings. Only if team needs, they will conduct meetings. Scrum contains cross-functional team. Cross-functional team is nothing but there are different teams involved to develop project like testing team, development team, product manager, Scrum Master and so on. Whereas in Kanban, roles are not fixed. Team members must change roles based on project. So Scrum contains product manager, Scrum Master and development and testing team. And whereas in Kanban, there are no proper roles because roles keep on changing based on project. These are differences between Scrum and Kanban. Next I will explain what is DevOps and then I will explain DevOps lifecycle, best practices and principles of DevOps, difference between agile and DevOps. At first I will explain what is DevOps. Guys, before explaining what is DevOps, you need to know what is server. Guys, each and every software company maintains servers. In simple terms, a server is 24/7 running system. Or you can also say server is big and powerful computer that works 24/7. Software companies will store and manage websites and applications by using server. Guys, I will give one real-time example so that you can clearly understand what is use of server. For example, if you consider Amazon website, anytime whenever you open Amazon website, you can access this website because this Amazon website is stored in server and this server is managed by Amazon company. For example, there is problem in this Amazon server, so you cannot access Amazon website. That is why servers must work 24/7. Even if server don't work for 1 minute, there is millions of loss for companies. For example, if you consider this Amazon website, every minute millions of people are using this website. So even if server don't work for 1 minute, there is huge amount of loss for companies. So server is big and powerful computer that stores and manages websites and applications. Now I will explain what is DevOps. Guys, DevOps stands for development plus operations, where DEV stands for development and OPS stands for operations. So DevOps is a combination of software development and operations. Guys, the main duty of this development team is they will develop and test a software application. After developing application, this operations team will place that application in one server. So placing software application in server is known as deployment. So software development team will develop application and test application, and whereas operations team will place that application in one server. So DevOps is a combination of software development and operations. So DevOps is a software development process which aims to integrate the work of development team and operations team by facilitating a culture of collaboration and sharing responsibility. Guys, DevOps is a software development process. Software development process is nothing but sequence of steps that we need to follow in order to develop any application or software. This DevOps will integrate work of development team and operations team. Guys, in DevOps, both the development team and operations team, they will interact with each other and they will complete work. They both communicate each other and they will share responsibility to develop and deploy software. So DevOps is a software development process which aim to integrate the work of development team and operations team by facilitating a culture of collaboration, that is they will collaborate each other and share responsibilities. It first I will explain what is software development. Shortly we call it as DEV. Developers will write code and they will create wonderful applications. This is known as software development. Next I will explain what is role of operations team. Employees in the operations team are like the protectors of the digital world. That is, they will take care of deployment, managing and keeping application running smoothly in real world. This operations team will deploy. Deploy is nothing but placing our application in one server is known as deployment. Whenever operations team places software in particular server, users can access that application. Even after making application available to users, that is, even after placing application in server, operations team must provide security to that application and they need to manage that application. So that application will run smoothly in internet. Guys, digital world is nothing but internet. So main duty of operations team is they need to place application in server and also they have responsibility to make application running in internet smoothly. So in DevOps, development team and operations team works together in order to create, build and deliver application. So DevOps mean people working together to create, build and deliver software quickly and securely. It's all about making the process faster and better by using automation, teamwork, quick feedback and learning from mistakes. In DevOps, in order to create application, in order to build application and in order to deploy application, DevOps team will use various automation tools so they can complete work faster and better. DevOps is also based on agile approach. That means DevOps and agile has only one goal, that is they need to improve software development process. That is they need to deliver software quickly and efficiently and that software must reach customer expectation. By using agile process they can improve software development, and whereas DevOps is collaboration between development team and operations team in order to improve software development process. Guys, next I will explain DevOps lifecycle. Guys, this is complete DevOps lifecycle. These are various stages. First one is plan, next one is code, build, test, release, deploy, operate, monitor, and again plan, release, code, build, test. This loop will continue. Initially for basic version of software, they will perform all these operations. Again for new version, they will perform same thing. So this will work like a loop. Guys, in this DevOps lifecycle, all these stages are classified into two parts. They are development and operations. I will explain all these stages one by one in detail. In DevOps lifecycle, first stage is plan. This plan stage comes under development. Guys, for example, I am college owner. I want to design one college software. So in software company, I will meet project manager and I will discuss about my software. Guys, for example, I said that my college software must contain student login form, faculty login form, student details, faculty details, student attendance, faculty attendance and so on. So all these are considered as futures. So project manager will note down all my futures and then he will plan development process. In this, developers, project managers and all employees, they will collaborate each other and they will design goals and scope of the project. In DevOps for this planning phase, they will use Jira tool. Guys, this is real-time example of planning stage. Guys, for example, I said that I want college software. So it is considered as Epic. And in that college software, I said I want student login form, employee login form, and faculty attendance, student attendance and so on. So all these are considered as user stories. Student login form is one story, employee login form is one story, student attendance is one story and so on. All these are considered as user stories. So in Jira tool, project manager will create epics and stories. And then project manager will assign tasks to various developers using Jira tool. And also you will track how work is going on this Jira tool. This is all about plan stage. Next one is code stage. As we know, this code stage also belongs to development. Based on features given by customers, developer will start writing code. For example, if developer is creating Java application, he will write Java code. Similarly, for Python application, he will write Python code. And if he is creating website, he will write HTML code. Like that, based on application, he will write different kinds of code. Guys, in software companies, only single developer will not write entire code. I will give an example. For example, Software company is creating college website. Only one developer will not write entire code for this college website. There are various developers involved. For example, one developer is creating student login form for this college website. Next developer is creating faculty login form. Next developer is creating student attendance form. And next developer is creating faculty details form. Guys, all these developers will install Git software in their computers. For example, this developer will install Git in his computer. Similarly, all developers will install Git in their computer. Git is nothing but Git is a software. That software will work based on commands. So Git is a software that works based on commands. So whenever developer writes any code, he will store that code in Git software. So in developer's computer, he will store that code in Git software. Similarly, he will develop code and he will store in Git software. Like that, all developers will develop code and they will store that code in Git. For example, this employee want to see code written by this employee. And similarly, this employee want to see code written by this employee. So they cannot see directly. So directly he cannot access this system. That is why they will use GitHub. Guys, this GitHub is nothing but it is a website. After developer writing entire code, he will store that code in Git. From that Git software, by writing some small line of command, they can store that code in GitHub. So GitHub will store Git repositories. Git repository is nothing but in which place our code is present in Git software, we call it as Git repository. So GitHub is a website that will store these Git repositories in cloud. So all remaining developers can see code which is written by this developer. Similarly, this developer developed faculty login form. So immediately from this Git, he will store that code in GitHub. Similarly, this both developers developed student attendance form and student details form. They both will place that code in this GitHub. So whenever they place code in GitHub, all remaining developers in project can access this code. Guys, this Git and GitHub both are connected to each other. Whenever this developer modify any code in this Git, automatically by writing small line of command in Git, we can push these changes to GitHub. Guys, we can keep on updating code in Git. So Git is a version control system, that is it is a software that works based on commands. Guys, in Git, for each and every operation, you need to write commands. Whereas GitHub is a web-based platform, that is it is a website and it will provide service, that is it will host Git repositories in cloud. Guys, in GitHub, there is no need of writing any commands. It is graphical user interface. So GitHub is a place where our code is stored and all remaining developers in our project can access that code. This makes developers easy to manage projects. Guys, whenever any developer made any changes in code, who made changes and when he made changes, that is seen in GitHub. So in DevOps code stage, these are tools that we use. One is Git, next one is GitHub and next one is GitLab. Guys, GitHub and GitLab both are same, but they are developed by different companies. Next one is build stage. This build stage also belongs to development. Developers compile source code into executable binaries or artifacts that can be deployed and run. Continuous integration tools automate this process, that code changes are constantly built and tested. For example, software company is designing college website. Initially nothing is developed. Guys, for example, this developer written student login form code. After successfully completion of entire code, he will place that code in GitHub. Immediately whenever developer places code in GitHub, automatically that code is compiled and tested. If there are no errors, then executable file is generated. Okay, this executable file is nothing but we call this executable file as artifacts. That is nothing but code which is under working condition. So from this GitHub, code is automatically compiled and tested and then artifact is created. This process is known as build stage. And this entire process will take place by using automation tools. So whenever developer push new code into GitHub, automatically that code is compiled and tested. For example, this code is successfully executed and tested and artifact is generated, then automatically that code is sent to server. For example, this faculty login form is also automatically tested and if everything is working well, then automatically that code is deployed into server and this faculty login form is also seen in website. And this build process is done by using various automation tools like Jenkins, Circle CI and Travis CI. Guys, mainly we will use this Jenkins. Developers compile source code into executable binaries or artifacts that can be deployed and run. They will run in server. Continuous integration tool automates this process. This process is continuously automated by using continuous integration tools. Whenever developer add any new code, that is continuously built and tested. So example is Jenkins tool. Jenkins is set up to automate the build process. Whenever developers push code changes, to GitHub repository. Whenever developer make any changes in GitHub, Jenkins automatically get that notification. Then Jenkins will automatically compile that code and test that code, and that will create artifacts or packages for deployment. And fourth one is test stage. As we know, software testers will perform testing. This testing stage also comes under development, but operations team also involved in this testing, because even after successfully placing our software in server by operations team, that is still after software is available to users, there is chance for bugs and errors even after releasing our software. So testing is primarily development activity, but operations team also involved in this testing. In DevOps testing stage, there are so many types of tools available in order to perform unit test, integration test and so on. So these are some of the famous tools in order to perform testing in DevOps. They are JUnit, Selenium and Postman. By using these kinds of tools, they can perform unit test and integration test. And next sixth one is release stage. Once after successfully completion of testing, if software is working well, development team will contact to operations team, and this development team will handle that software to operations team. Then operations team will handle tasks like configuring server and deploying application. Guys, normally in release stage, they will deploy application in dummy server. If everything is working correct, then they will deploy that application in actual server. So one of the famous tool is Ansible. By using Ansible tool, we can deploy application in server. And sixth one is deployment stage. In release phase, if everything is working in dummy server, then they will place application in actual server, that is production server. And this deployment is handled by operations team. Operation teams are responsible for deploying the application to production server or cloud. They ensure the deployment process is smooth, minimize downtime, and follow best practices for reliability and scalability. This operations team is completely responsible to complete this work smoothly. At the same time, they will provide security to that application. So these are famous tools for deployment. One is Docker and next one is Kubernetes. Normally many of the companies use Kubernetes. Guys, what Docker will do is, Docker will create Docker image and then it will save that image in Docker container. After successfully placing Docker image in container, guys, this Kubernetes is present in production server. So this containerized application is stored in Kubernetes. And seventh one is operate stage. Operate stage is also handled by operation team. In the team, they will check application performance. That is whether application is working correctly or not. Grafana is one of the famous tool in order to monitor application performance. And last one is monitor stage. This monitoring stage is also handled by operations team. In this operations team use various kinds of monitoring tools like Nagios. In that they can easily identify that how much memory that software is consuming and also how much CPU power it is consuming, and within how much time that software is giving response, how much error rate. All this can be monitored by using monitoring tools like Nagios. Guys, this is all about DevOps lifecycle. Guys, if you see this diagram is like a loop. That is nothing but it is continuous process. For each and every new update in that software, all this process is automated by using various kinds of tools. This is entire process how development team and operations team communicate each other. Thus, plan, code, build, test and release belongs to development, and deploy, operate and monitor belongs to operations team. Next, I will explain best practices and principles of DevOps in order to improve collaboration and efficiency in IT operations. And the first principle is automation. In DevOps, instead of building and testing software manually, they will use automation tools in order to perform repetitive tasks. If they use automation tools, work will complete very faster and it will reduce mistakes. Second one is collaboration and communication. In DevOps, all employees will communicate each other and they will complete work smoothly. Third one is continuous improvement and minimizing waste. DevOps team always want to make things better. So DevOps team will use automation tools for repetitive tasks and their focus is to release software very quickly. If any problem occurs in middle, they can solve errors very fast by using automation. Fourth one is hyper focus on user needs with short feedback loops. Guys, DevOps team always focus on what user wants. Whenever user want any changes in software, by using automation, DevOps team will complete the changes in software and they will satisfy users. Fifth one is infrastructure as a code. Shortly we call it as IAC. In order to place any software in server, at first they need to configure that server. So they will use some automation tools in order to configure server instead of doing it manually. So instead of setting up servers and other infrastructure manually, they will use some automation tools in order to configure server. So work will complete very faster. Sixth one is continuous integration. Whenever developer perform any changes in code in order to update software, then that code is automatically tested and that update is automatically integrated to existing software. So whenever someone make a change to the code, put it in a shared place right away. That is nothing but they will place that code in Git repository. This makes sure that everyone's changes are tested together, which helps find and fix problems earlier. Whenever any developer make any change, that code is tested, and if any problem occur, then it is easy to identify that problem. And seventh one is continuous delivery. Once if software testing is successful, then that software is placed in production server. Then users can access the software and even they will perform this operation by using automation tools. Eighth one is security by design. As we know, many hackers are involved. So providing security to software is very important. So even here they will use automation tools in order to provide security. Ninth one is scalability and resilience. Whenever we create any software by using DevOps, that particular software will be used by many of the users. So even if many people use our software, that software must not stop unexpectedly. So building software is like building bridge. In same way how bridge will handle heavy traffic, our software must handle many users. Even if many users use our software, it should not break. Still it must keep on working. 10th one is monitoring and logging. Even after placing our software in server, daily we need to monitor that application. Like we need to check whether software is working correctly or not. Like whenever something goes wrong, automatically software must give us alert messages. And also we need to monitor how software is consuming memory and CPU power. If there are any errors in software, whether it is accessible to all users, we need to monitor each and everything. By using Grafana and Nagios tools, we can monitor. In DevOps, by using tools like Nagios and Grafana, we can monitor our application. These are various principles and practices in DevOps. Next, I will explain difference between Agile and DevOps. Guys, both Agile and DevOps are software development process. That is nothing but sequence of steps they will follow in order to deliver software. And they both have same goal, that is, they need to deliver software quickly and efficiently within short period of time that must reach customer expectations. But major difference between Agile and DevOps is, this Agile is a process that contains principles. Principles are nothing but rules that we need to follow in order to develop software. But whereas DevOps is all about continuous deployment of software. In DevOps, they will use various automation tools in order to deliver software quickly. So DevOps mean how development team and operations team communicate each other in order to deliver software quickly. These are some of the differences between Agile and DevOps. Agile was introduced in 2001, whereas DevOps in 2008. In Agile, customer will give feedback, whereas in DevOps, internal team will give feedback. In Agile, developing software has highest priority, whereas in DevOps, developing, testing and implementation all are equally important. Agile will not focus on automation, whereas in DevOps, they will complete entire work by using automation tools. In Agile, they will focus on constant changes. That is, what are the updates given by customers, and based on that, how to change existing software. They will focus on that. Whereas in DevOps, they will focus on constant testing and delivery. Agile refers to a continuous iterative approach which focus on collaboration, customer feedback, and small and repeat releases. Agile is continuously iterative process, that is, in Agile, they need to update same software again and again, and all employees will collaborate each other by conducting daily meetings. They will take regular feedbacks from customers and immediately they will release updated version of software. Whereas in DevOps, development team and operations team will communicate each other in order to develop software. In Agile, they will complete work in the form of sprints. Sprint is nothing but time given in order to develop each feature. Approximately 2 to 4 weeks of time is given in order to complete each sprint. Whereas in DevOps, they will deliver code to production team on daily basis. Immediately whenever new code is written, that is automatically tested and released to production team. Agile will use very small team, that is approximately 9 to 10 members. And whereas entire company will follow DevOps. So DevOps is company-wide strategy. These are differences between Agile and DevOps. Next I will explain continuous integration, continuous delivery and continuous deployment in DevOps. And also I will explain common bottlenecks in DevOps CI/CD process and how to overcome them. At first I will explain what is continuous integration. Shortly we call it as CI process. So whenever developer write any code or modify any code, then they will check in that code into source repository. That is nothing but whenever developer write any code or modify any code, then he will place that code into Git software. And by writing small lines of commands in Git software, they will transfer that code from Git to GitHub. GitHub is nothing but it is a website.
So whenever developer add or modify any new code into GitHub, then that code is automatically sent to CI server. Jenkins software is example of CI server. Then the CI server will perform build and test operations on that code. For example, I am developer. I placed new code in GitHub. So whenever I place code in GitHub, automatically Jenkins will get alert message. In Jenkins, by using tool like Maven, they will perform build operations. That is nothing but they will compile and execute my code. So Maven tool will perform build operation. That is nothing but this Maven tool will compile and execute my code. After successfully compiling and executing my code, then this Jenkins will perform test operation. Guys, basically we will perform two kinds of test. One is unit test and next one is integration test. By using tool like JUnit, we can perform unit test, and whereas by using tool like Selenium, we can perform integration test. So if build and test is successful on my code, then artifact is generated. Guys, artifact is nothing but working software. It is collection of packages. The file which is working is known as artifact. So after successfully building and testing my code, then artifact is generated. For example, if we get any failure in build and test operations, automatically that notification is sent to developer. So again developer need to modify that code and he need to perform same operation again. This is all about continuous integration process. So whenever developer places code in GitHub, automatically Jenkins will get that message, and whereas in Jenkins, by using tool like Maven, we can perform build operation. Build is nothing but compiling and executing. After successfully compiling and executing, by using tool like JUnit, we can perform unit test, and whereas by using tool like Selenium, we can perform integration test. After both build and test operations are successful, then artifact is generated. For example, if there is any failure in build and test operations, that notification is sent back to these developers. Again, developer need to modify that code and he need to perform same operation again. This is continuous integration process. Guys, this is example how continuous integration process will work. Developer writes code and push it into a version control system like Git. Jenkins then monitors these repositories for changes. Guys, repositories are nothing but place where our code is present. We call that place as repository. So Jenkins will identify that whether any changes occurs in our code. Whenever changes are detected, then Jenkins will pull that code. Jenkins will take that code. Typically using a build tools like Maven or Gradle, they will build a project. By using tools like Maven or Gradle, we can perform build operation. After building, Jenkins may run unit test using tools like JUnit and integration test using tools like Selenium. The results of the test are typically reported back to Jenkins, whether the test is successful or failure. That is sent back to Jenkins. If build is successful, Jenkins may proceed to package the application into an artifact. Our application which is under working condition is known as artifact. Generally, artifact is a file which is under working condition. Whether that file can be jar file or var file, or it can also be a Docker image. This is all about continuous integration process. Next, I will explain what is continuous delivery process. Jenkins, after successfully creating artifact, we need to place that artifact in one duplicate server to check whether software is working smoothly or not. This is known as continuous delivery process. Shortly, we call it as CD process. So continuous delivery is nothing but placing our software in one dummy server in order to check whether application is working correctly or not. So developers, after writing code, check-in is nothing but after writing code, they will place that code in GitHub. From that GitHub, continuous integration test is performed. If it is successful, then artifact is generated. That artifact is placed in one mock server. Mock server is nothing but dummy server. Guys, before placing our software into one dummy server, at first we need to configure that server, and that configuration is done by using tool like Ansible. By using Ansible, we can configure our server. So in continuous delivery, the packed application is automatically prepared for release to production. They will not release, they will just prepare application in order to release to production. This can involve tasks like further testing, environment configuration, and final validation before deployment. So after placing application in dummy server, they will perform further tests like whether application is working smoothly or not after placing it into server, whether there are any errors, and it is considered as final validation before deployment. Before actually placing application into original server, this is final verification. If everything goes well here, then they will place that application into actual server. So in continuous delivery process, in order to configure server, we need to use tool like Ansible. Guys, from placing code to GitHub, continuous integration continuous delivery, and continuous deployment. All this is automated by using various kinds of tools. Human beings will not perform all these tasks manually. All these tasks are automatically performed by using various kinds of tools. So this is example. In continuous delivery, Ansible will automatically configure server based on our application. Once everything is validated on sample server, the application is then ready for release to actual production server. So if we perform this operation on sample server, we will not face any problem on production server. This is all about continuous delivery. Next I will explain what is continuous deployment. Guys, CD stands for continuous delivery and continuous deployment. Continuous delivery is nothing but placing our application in sample server, whereas continuous deployment is nothing but placing our application into actual production server. If we place our application into actual production server, all users can access that application. For example, if you consider Amazon application, we all can access Amazon application because that application is present in production server. So whenever we place any application in production server, all users can access that application. As I already said before, this continuous integration, continuous delivery and continuous deployment. All these operations are performed automatically by system itself. Human beings will not involve. So in continuous deployment, every successful build automatically goes into production without human intervention. Guys, production server is nothing but Kubernetes. We will place our application in Kubernetes, where this Kubernetes is production server. So deployment is nothing but placing our application into production server like Kubernetes. So tools like Kubernetes is used for automatically deploying and managing application into production server. So basically this Kubernetes software is present in our production server. So we will place our application in Kubernetes. So this is example. After Jenkins build and package the application, Kubernetes is used to automatically deploy the Docker image into production environment. Guys, we will not place our application directly into Kubernetes. Instead, what we will do is, by using software like Docker, we will convert our application into Docker image. And then we will place our application into Docker container. Then we will place that containerized application into Kubernetes. This is example. Developers will place code into GitHub. After placing code into GitHub, automatically continuous integration will take place. After that, continuous delivery will take place. And at last, continuous deployment will take place. That is nothing but placing our application into actual production server. Guys, this is complete CI/CD pipeline. So developers, after developing code, they will place that code into GitHub. After that, build and test is performed by using Jenkins. Then artifact is generated. Then Ansible will perform configuration on our server. So by using Docker application, we will create Docker image. We will place the Docker image in Docker container. After that, we will place our application in dummy server. If everything goes well, we will place that application in production server. Guys, this is complete CI/CD process pipeline. Next, I will explain common bottlenecks in DevOps CI/CD process and how to overcome them. And the first one is limited automation. Guys, if you perform continuous integration and continuous deployment manually by human beings, then it will take a lot of time. That is why in DevOps CI/CD process, we will completely use various automation tools in order to perform all these operations automatically. Second one is slow feedback loops. Guys, whenever any person gives us project, then immediately we need to develop that project and we need to release that project. So if we release application immediately, then user can easily identify and then he may give some changes. So waiting too long for feedback can delay development process. So solution is to optimize test and build process to run faster. So if we develop application very fast, then immediately we will get feedbacks from users. Third one is complex configuration management. Guys, manually configuring server is very tough. So in DevOps, we will use tool like Ansible in order to automatically configure our server. So it will save our time. And fourth one is poor collaboration. Guys, in DevOps, development team and operations team, they both must collaborate each other and complete work. So for this, they can conduct daily meetings and they can interact each other. Fifth one is inadequate monitoring and logging. Guys, even after placing our application in server, we need to check that whether application is working smoothly or not. So in DevOps, for monitoring and logging, we can use tools like Prometheus for monitoring and whereas ELK stack for logging. And last one is manual release process. Guys, if we release our application manually without using any automation tools, it will consume lot of time and there is high chance for errors. So in order to automate release process, That is, in order to perform continuous integration and continuous deployment, we need to use tools like Jenkins, Ansible, Kubernetes, etc. so that within short period of time we can release our software, that too with no errors or very few errors.
Next I will explain role of automation in DevOps, examples of popular automation tools, what are artifacts and what is artifact repository, and also I will explain monitoring and feedback stage in DevOps. Guys, role of automation in DevOps is nothing but we will automate repetitive tasks. For example, whenever developer writes any new code, that code is automatically compiled and executed, and then that code is tested, and if everything is working well, that code is automatically placed in server. Here in DevOps, all this work is automated by using various kinds of tools. So the role of automation in DevOps is to automate repetitive tasks, improve efficiency and ensure consistency through the software development lifecycle. Here by using automation, we will achieve efficiency and consistency. Efficiency is nothing but complete work is done by various kinds of automation tools. So we will complete work in very short time. So we will achieve efficiency. And consistency means correctness. As complete work is done by various kinds of automation tools, there is less chance for errors. So complete work will be correct. This is meaning of consistency. So by using various kinds of automation tools, we will achieve efficiency and consistency. These are various kinds of automation tools in DevOps. First one is Jenkins. Whenever developer writes any new code, that code is automatically built. Build is nothing but compiling and executing. So building, testing and deployment. Complete work is automated by using Jenkins software. And whereas by using tool like Maven, we will perform automate build process for Java based projects. Whereas this JUnit and Selenium are testing tools, we will perform testing. Whereas by using JUnit we will perform unit test, and whereas by using Selenium we will perform integration test. And whereas by using tool like Ansible, we will configure our server. Before actually placing application in our server, at first we need to configure our server. So that work is done by Ansible. And whereas by using Docker, we can create Docker image, and then we can place the Docker image in Docker container. Guys, we will not place our application directly in server. At first what we will do is, we will convert our application into Docker image, and then we will place that application in Docker container, and then we will place that containerized application in server. So by using Docker tool, we can create Docker image and we can place that image in Docker container. Guys, whereas Kubernetes is software and the software is present in server. So after creating Docker image and placing the Docker image in Docker container, we will place that containerized application in Kubernetes. So we will place our containerized application in Kubernetes. And whereas GitLab and GitHub are websites, whenever developer write any code, he will place that code in GitHub website. So whenever developer places code in GitHub, then continuous integration and continuous deployment takes place. And whereas this CHEF is infrastructure configuration and management tool. That is nothing but we can configure softwares, databases, storage devices, servers, etc. And whereas this Puppet tool is IT infrastructure management tool, and whereas Terraform is cloud infrastructure management tool. These are various tools that we use in DevOps. Next I will explain what is artifact. Guys, artifact is nothing but executable file. For example, I am developer, I written code. Whenever I write this code and I place that code in GitHub, that code is automatically built and tested. Build is nothing but compiling and executing. If compiling and executing is successful, then that code is tested, and if the testing is successful, then artifact is generated. Artifact is nothing but our working software, and this artifact is a file. This can be any file like var file or rar file or any other file, and we will store this artifact in one location. We call that location as repository. So artifact repository is nothing but where our artifacts are stored. We call that location as artifact repository. There are two types of artifact repositories. They are JFrog and Docker. So in DevOps, artifact refers to the output or result of the software build process. These artifacts can include compile code, executable file, documentation or any other files generated during build process. After successfully completing build process, artifacts will be generated. Either that artifact can be any file, either var file or rar file or any other file. And these artifacts are created as a part of CI/CD pipeline and used for deploymenting and releasing software. These artifacts are created in continuous integration and continuous deployment process. And next one is artifact repository. This artifact repository is also known as binary repository. or we can also call it as artifact management system. It is a centralized location where these artifacts are stored and managed. We will store all our artifacts in one location. We call that location as artifact repository. So it serves as a secure and reliable storage solution for storing and versioning artifacts through the software development lifecycle. Not only we will store artifacts, we will also provide security to that artifact. So no hackers can hack that artifact. So not only we will store artifact, but also we will provide security. So no hacker can hack that artifact. Normally there are two popular artifact repositories in DevOps. They are JFrog Artifactory and next one is Docker. Next I will explain monitoring and feedback stage in DevOps. Guys, monitoring and feedback stage is one of the important stage in software development process because we can track our software performance. Guys, whenever we develop any software, still there is chance for errors. Software will not work correctly all the time. For example, I developed one software. The software may work in one system or that software may not work in another system. For example, one user can access the software and whereas another user cannot access the software. Even after deployment, we need to monitor our software to check whether the software is working correctly or not. So by using various kinds of monitoring tools and logging tools, we can track system performance, user behavior and also system behavior. That is whether software is giving correct response to users or not. And by using alert systems, we can quickly identify and fix issues. For example, if software is not working properly or consuming lot of memory or system is working slow, if any such issues occur, automatically alert message is sent to developers. And also development team and operations team will interact each other and they will take regular feedbacks like how the software is working. They will perform various kinds of activities. These are various kinds of activities. First one is setting up monitoring tools. Guys, normally in software companies, there will be separate team in order to monitor software performance. Like if we install software, how much memory the software is consuming, how much CPU power it is consuming, and what is response time, what are error rates, what is our system performance, what is user behavior. They will monitor everything. So in order to monitor all this in DevOps, they will use various kinds of tools like Prometheus and Grafana. And next one is logging. Guys, whenever any user log into that particular software, complete information is stored in logging tools. Like what activity that user performed on that software, how much time is spent on that software, for what kind of user input, how that software is responding. Complete information is stored in logging tools. There are various kinds of logging tools that are used in DevOps like ELK, Splunk and etc. And by using these tools, we can collect, we can store and we can analyze log data. And third one is alerting. For example, I developed one software. That software is not responding properly and it is consuming lot of memory. So whenever it is consuming lot of memory, automatically I will get one alert message. So immediately developer will take action. So if we set alert systems, whenever any matrices exceeds, automatically we will get alert message and we can fix that issue. And fourth one is analyzing data. Guys, analyzing data is nothing but after collecting complete data from monitoring and logging tools, that complete information is represented in the form of bars and charts. So by seeing that graphs and charts, we can clearly identify performance of our software. And fifth one is feedback loop. So based on feedbacks from monitoring and logging tools, developers team and operations team will interact each other and they will fix that issue. And last one is continuous improvement. So if we continuously monitor our software and take feedbacks, we can easily fix that issue and we can improve our software performance. These are various kinds of monitoring tools. They are Grafana, Nagios, Prometheus, Datadog, etc. And whereas for data visualizing, we'll use tools like ELK Stack, New Release, etc. Next, I will explain release management in DevOps. Release management in DevOps includes scheduling, planning, and controlling software development process across development, testing, pre-production and production environments. Guys, release management is nothing but controlling entire software development process from developing software to placing that software in production server. Controlling this entire process is known as release management. When to start and when to manage and complete all these stages comes under release management. This release management typically involves version control, continuous integration and continuous deployment pipelines, automated testings, deployment automation and monitoring. Guys, version control is nothing but placing our code in Git and GitHub. After placing our code in GitHub, automatically continuous integration, testing and deployment. All these works are done automatically by using various kinds of tools in DevOps. These tools are known as automation tools. In DevOps, we will use various kinds of automation tools in order to complete entire work, from developing software to placing our software in production server. So if we use automation tools, our work will complete very fast, that way with very few errors or without any errors. So this will be good for business and as well as users. So in simple terms, release management in DevOps is all about making sure that when we release or update any new software, everything goes smoothly, and this entire work is done by using automation tools and processes. Guys, in the software development process, release manager will perform scheduling, planning and controlling software development process, when to start that software and how to complete the software. This entire control is under release manager. And next one is product owner. What kind of software user want and what are the features that must be present in the software. Everything is prepared by product owner. And whereas testing manager is responsible for testing software in order to make that software bug free, and whereas security team will provide security to that software. And last one is DevOps. DevOps team will automate entire work by using various kinds of tools, from writing code to placing that software in production server. Complete work is automated by using DevOps team. Here DevOps team will use various kinds of tools in order to complete entire work. These are some of the challenges in release management. First one is coordination. When to develop software and when to release that software. All team members in company like developers, testers, managers, they all must coordinate each other, and they need to complete work in smooth way, and they need to release software as soon as possible. So when to complete software and how to complete software, everything is decided by all team members by coordinating each other. And second one is complexity. Guys, for example, if you develop any software, it may work in one system or it may not work in another system. So here you need to manage complexity. That is nothing but dealing with different environments, like on your computer versus a website. So make everything fit together smoothly. And third one is risk management. Whatever the software that we develop, we need to make sure that software is working smoothly without any errors. In case if there are any errors, immediately we need to fix that errors so it will not cause any problems to users. And fourth one is time pressure. Guys, in DevOps, we need to develop high quality software, that too in short period of time. We need to face all these challenges in release management. Next one is benefits of release management. First one is consistency. In DevOps, if you want to develop any new software, then again we need to follow the same steps, so it will avoid mistakes and confusion. And second one is efficiency. DevOps will not focus on unnecessary steps. So without wasting any time, DevOps process will complete software faster and smoother. And third one is quality assurance. Before actually placing software in original server, in DevOps we will place software in dummy server. If everything is working well in dummy server, then we will place that software in original server. So it will avoid bigger issues. And fourth one is customer satisfaction. One and only goal in DevOps is customer satisfaction. How we can satisfy any customer? We can satisfy any customer by releasing high quality software in short period of time. These are benefits of release management. Guys, these are popular companies using automated release management without disturbing services. For example, if you consider Netflix, daily new movies are releasing in Netflix without disturbing any service. So Netflix, Amazon, Spotify, automated release management without disturbing any service. Next I will explain relationship between DevOps and ITIL. Guys, ITIL stands for Information Technology Infrastructure Library. Guys, this ITIL is nothing but it is a guidebook. It is like a handbook. By following this handbook, we can manage IT services. This handbook covers various things like fixing problems when they come up, making changes to computer systems, and handling user requests. This handbook covers all these things. And whereas ITIL lifecycle contains set of steps that shows how IT services are planned, built and delivered over time. Overall, this ITIL is like a roadmap for managing IT services. And whereas DevOps is a teamwork for software. That is nothing but development team and operations team will communicate each other and they will develop software. And also in DevOps, we will use various kinds of automation tools in order to complete entire work. And in DevOps, we will keep everyone sync. In DevOps, what kind of work is done by various kinds of employees, we can see complete information. So make sure that everyone involved in making software is on the same page and knows what they are doing. But how DevOps and ITIL works together? First one is similar goals. Both DevOps and ITIL has one goal, that is use technologies in order to reach goal. So both ITIL and DevOps want to make sure that technology helps a company reaches its goal. Second one is improving process. ITIL will give plan for managing IT tasks, and whereas DevOps will give various kinds of tools for completing work faster and in better way. Third one is teamwork and communication. Guys, ITIL will say that everyone must be on same team. That is, everyone must work together in order to complete work. So even in DevOps, both development team and operations team will communicate each other and they will complete work. So both DevOps and ITIL have same idea. That is, everyone must work together. And fourth one is making things easier with automation. Guys, ITIL says that we need to complete work in smooth way, that too with very less mistakes. But in order to achieve this ITIL goal, we need to use DevOps tools. So DevOps focus on automating repetitive tasks, which can make ITIL process smoother and less prone to mistakes. Here ITIL focus on how to develop IT services, and whereas DevOps focus on how to develop and release particular software. So even though both focuses are different, they both can team up so that companies run smoothly and keep customers happy. Next I will start unit 2. I will explain all these topics in detail. At first I will explain impact of DevOps on achieving business agility. Guys, meaning of agility is ability to move quickly and easily. And whereas business agility means a company can easily adjust to market changes by being flexible and quick to adapt. Guys, for example, if you consider Samsung company, long back Samsung company produced normal smartphones, and after few years Samsung company produced 2G mobiles, and then 3G mobiles, and then 4G mobiles. Now Samsung company bought 5G mobiles. So based on user requirements, Samsung company immediately launched new smartphones. So here Samsung company easily adjusted to market changes by being flexible and quickly adapted to new features. So any company that can easily adjust to market changes by being flexible and quick to adapt is known as business agility. So by using DevOps, any company can achieve business agility. That is nothing but any company can easily adjust to market changes by being flexible and quick to adapt. As we know, in DevOps, development team and operations team will work together. And here in DevOps, they will use various kinds of automation tools. By using various kinds of automation tools, they will automate complete tasks. And they will keep on updating same software frequently. So whenever any customer want new feature in that particular software, then immediately customer will respond to that company. And then by using various kinds of automation tools, immediately company will update that particular software. So by using DevOps, companies can reach faster to changes in market. So how DevOps helps to achieve business agility means by using various kinds of automation tools, DevOps helps to achieve business agility. Guys, I will give one simple example. Guys, for example, one company is not following DevOps. As we know, in company there will be development team and there will be operations team. Duty of development team is to write code and duty of operations team is to place that code in server. If company don't follow DevOps, that means, so if company don't use any kind of automation tools, after developers writing code, then it will take a lot of time to place that code in server. For example, customer gave project to this developer written code, and then developer submitted this code to operations team, then operations team placed this code in server, and after few days, customer said to update this same software again, but it will take a lot of time because this company is not following DevOps, that is, this company is not using any kind of automation tools. For example, now the same company is using DevOps. Whenever customer said to update this same software with new feature, immediately developer will start writing code, and immediately by using various kinds of automation tools, testing is done for this particular code, and then automatically without human intervention, this code is placed in server. So here DevOps will use various kinds of automation tools in order to complete work very fast. So with DevOps, they implemented automated systems, that is nothing but they are using various kinds of automation tools that allows developers to send their code straight to deployment. That is nothing but our code is directly placed in server. So this means new features and updates can reach customers much faster and able to adapt quickly to customer feedbacks. So whenever customer give new feedback, immediately they will update that code. These are various kinds of companies that are using DevOps in order to achieve business agility. And the first company is Amazon. As we know, in Amazon daily they will launch various kinds of products. Guys, e-commerce platforms are nothing but online shopping sites. For example, Amazon.in. So by using DevOps, new updates and features are automatically placed in Amazon.in. Guys, for example, in festival seasons, millions of people will do shopping in Amazon. So by using various kinds of DevOps tools, They will smoothly handle increased traffic and also transactions. Next company is Netflix. Netflix also depends on DevOps to continuously enhance their streaming services, like they will launch movies, web series, so on, and this is done by using DevOps. And third company is Google. Google always focus on working together and they know clearly about what is happening. So even Google also use various kinds of automation tools in order to check errors in the code and quickly deploy updates. Next company is Microsoft. Even Microsoft also use DevOps tools. For example, if you consider Microsoft products like MS Office, Windows, so on, to update these products frequently, Microsoft will use various kinds of DevOps tools. So while releasing these updates, they also focus on user feedback and as well as security. And last company is Adobe. For example, if you consider Adobe products like Photoshop, Illustrator, while creating these creative softwares, they use DevOps. Next, I will explain continuous testing in DevOps. In DevOps, continuous testing means testing your software non-stop from the moment you start writing it to until it is ready to place in a server. Guys, whenever you develop any code, we need to perform various kinds of testings after writing code. In DevOps, all these testings are performed automatically by using various kinds of tools. So it's about automating tests, so they run automatically whenever there is a change. Helps to catch bugs early and ensure the software works well. As for example, I created college website. In this college website, initially I created only student login form and faculty login form. After conducting various kinds of testing successfully, I placed this website in server. For example, now I want to update this same website with new feature. Like for example, now I want to add student attendance and faculty attendance in this website. So again I written code for this. So whenever you make any changes in the software, again you need to perform various kinds of testings. So in DevOps, continuous testing is nothing but whenever you perform any changes to existing software, automatically by using various kinds of testing tools, testings are performed. So for these two features, again testing is performed. For example, again I want to update this website by adding student result. So I updated this code. After updating code, again I need to perform testing. So this is continuous process. For example, while I am performing automation test, I got to know that this student login form is not working well. So immediately again we can update this student login form and again we can perform testing. So by using automated testing, we can easily catch bugs early so that software will work well. Guys, in software development lifecycle, we need to perform various kinds of testings, starting when developer writes code to until before placing that code in server. In between this, we need to perform various kinds of testings. So in DevOps, continuous testing means testing your code non-stop from the moment when you start writing it to until it is ready to place in a server. It's about automating tests, so they run automatically whenever there is a change. Helps to catch bugs early and ensure software works well. So whenever developer update new code in that particular software, automatically testing is performed. Guys, there are various kinds of testings in this continuous testing. And the first one is unit test. Testing each piece of code separately to make sure it functions correctly. Guys, unit test is nothing but testing each part of code separately. For example, I am developing college website. In that college website, I written code for student login form, I written code for faculty login form, I written code for student attendance form, I written code for faculty attendance form. So testing each piece of code separately is known as unit test. Second one is integration testing. Integration testing makes sure that all the different pieces of the software fit together properly and works well together. Guys, as we know, in software company, in order to develop entire software, only single developer will not write entire code. One piece of code is written by one developer and next piece of code is written by another developer. So at last what they will do is, they will combine all this code. So after combining all this code, again they will perform testing. This is known as integration testing. Next one is functional testing. Functional testing ensures that the software features and functions behave as expected. As for example, in the student login form, we will enter username and password. But due to some error in this code, whatever the password that I enter, automatically it will open this website. So there is problem with this functionality. So we need to test functionality of each feature. So functional testing ensures that software features and functions behave as expected. Next one is regression testing. Regression testing confirms that new changes haven't broke existing feature. Guys, for example, initially I created a website. That website contained only student login form and faculty login form. Later on, I updated the same website by adding student results. So even though if we add new feature, existing features must work well. So regression testing ensures that new changes haven't broke existing features. And fifth one is performance testing. Performance testing ensures that how well the software performs under different conditions such as high user load. Guys, for example, in the software, student login form is working well, but at a time whenever 1000 users access this website, the student login form is not responding properly. So we need to check performance of our software. Our software must work on different conditions. And last one is security testing. So whenever we develop any software, after developing software, we'll give that software to hackers. So hacker will hack that software. If there is any weakness in our software, automatically hacker can hack that software. So security testing checks the software for any weakness and make sure that sensitive data is protected. Guys, these are various kinds of tools that we use in DevOps in order to perform various kinds of testings. By using tools like JUnit and TestNG, we can perform unit test, and by using tools like Selenium and Cypress, we can perform functional test. By using Jenkins and Travis CI, we can perform continuous automation and integration testing. And by using tools like JMeter and Gatling, we can perform performance testing. By using tools like OWASP and Nessus, we can perform security testing. These are the challenges that we need to face while we perform continuous testing in DevOps. And the first one is automation complexity. We need to perform various kinds of automation testing in various platforms. So it is time consuming. And second one is tool integration. Guys, we need to integrate testing tools with DevOps tools. It is very tough. And third one is test data management. In order to perform various kinds of testing on particular data, at first we need to store the data in particular place. Managing this data in order to perform testing is very tough. So ensuring the availability and manageability of test data for various scenarios and environments can be difficult. Guys, these are various kinds of benefits if we perform automation testing in DevOps. First one is early bug detection. We can easily find errors in early stage. And second one is faster feedback loops. So after performing testing, if anything is not working well, immediately they will take feedback and they will develop new code again. And third one is improved release confidence. If each and every test is successful, then we will get confidence and then we can easily release our software. Fourth one is cost and time saving. By performing various kinds of testings, we can easily find errors and we can easily fix that errors. So it will save cost and time. And last one is collaboration between development, testing and operations team. In DevOps, development team, testing team and operations team, all these teams will communicate each other and they will complete work. These are various kinds of benefits if you perform continuous testing in DevOps. Next I will explain monolithic architecture in DevOps. Monolithic architecture in DevOps refers to a traditional software design where all components of an application like front-end, back-end and database, all these are tightly integrated into a single code base, which means everything is kept together within a single folder. Guys, I will give one example so that you can clearly understand this definition. Guys, any application contains front-end, back-end and as well as database. For example, I am creating college application. In that college application, total I created 4 pages. One page is student login form, next one is faculty login form, next one is student attendance and next page contains student results. So in college website, whatever you see, we consider it as front end. So basically I created this front end application by using HTML and CSS. In student results page, whenever I enter my roll number and click on submit, automatically I can see my results. How it happened? Because in backend, I written some code by using programming language like Python, Java, C++. I written some kind of code. So whenever I enter my roll number and click on submit, automatically I can see my results. So in backend, we'll write some kind of code. Based on that, our application will work. And complete data related to this college application like student names, student results, student attendance, complete information is stored in database. So database is used to store information. Whenever you develop any application, if we store code related to front end, back end and as well as database in one place, then we call it as monolithic architecture. For example, I created college application. In that college application, I stored code related to front-end, back-end and as well as database in one single folder. Then we call it as monolithic architecture. The name itself says monolithic means single block, that is storing all these components in one single place. Monolithic architecture in DevOps refers to a traditional software design where all components of an application like front-end, back-end and as well as database, all these are tightly integrated into a single code base. Single code base is nothing but storing all these components in one single folder. This is known as monolithic architecture. This is diagram of monolithic architecture. Single code base is nothing but storing all these components in single folder or directory. Total there are three components. They are front end, back end and as well as database. Front end is nothing but user interface. We can create front end by using HTML and CSS. We call this front end as presentation layer. And next one is back end. Basically this back end contains business logic. In back end, we'll write code by using various programming languages like Java, Python, .NET, so on. So we call this back end as application layer. And third component is database. Database will store complete data related to application. So we call this database as data access layer because we can access data. So these are three components. So we can also call this monolithic architecture as three-tier architecture. In monolithic architecture, front end, that is user interface, and back end, that is business logic, and as well as data access layer, that is database, works as a single unit. So it is easier to manage all operations because all components of the software located in one place. As all these three components are located in one place, we can easily perform various operations. For example, I want to get student results. So whenever I enter my roll number in front end, automatically I can see my result. So we can easily manage various operations. In a monolithic architecture, changes made in one layer can affect other layers because they are tightly integrated. Guys, I will give one example. Guys, for example, I created Collating application. In this Collating application, I want to add new feature like I want to add new course page. For example, in this course page, whenever I click on CSC button, automatically it should display all subjects related to CSC. So again, I need to write code in backend by using programming language like Python, Java, so on. And again, I need to connect this course page to database. So in monolithic architecture, whenever you change one layer, then you need to change remaining layers too. And there is also another problem in monolithic architecture, that is, for example, if one layer is not working properly, automatically it will affect other layers. For example, due to some error, this backend is not working properly. So whenever I enter my roll number and click on submit, it will not show my results because this backend is not working properly. So if there is problem in one layer, automatically it will affect remaining layers. This is because in monolithic architecture, all these components are tightly integrated into a single code base. For example, I created a Collating website. In that Collating website, I want to add a new feature like adding new courses. So whenever I change presentation layer, I need to change business logic layer and as well as data access layer too. Next I will explain advantages of monolithic architecture. As we know, in monolithic architecture, everything is stored in one place. So develop, test and deploy becomes easy and communication between these components is very fast. As all components are tightly integrated, developers can easily understand entire application. In monolithic architecture, deploying application is very fast when compared to microservice architecture. Next I will explain what is this microservice architecture. These are disadvantages in monolithic architecture. First one is, it's challenging to update existing ones as the entire application need to be modified. Guys, I will give an example. Guys, this is Collating application which I created by using this monolithic architecture. Guys, for example, in this Collating application, I did one small spelling mistake. Like in login, I did not written I, just I written LOGN. So due to some spelling mistake, I need to change only front end. But as we know, front end, back end and database is stored in one place. So for this small change, again I need to place this complete code in GitHub and then I need to perform build and test operations for this entire application. I cannot perform build and test operations only for this front end. So I need to perform build and test operation for all these components. So it is challenging to update existing ones as the entire application need to be modified. And second one is, a fault in one part of application can bring down entire system since everything is tightly coupled. As I already said before, if there is fault in one layer, it will automatically affect remaining layers. And third one is, as everything is tightly coupled, it is difficult for teams to work independently, leading to coordination challenges. As complete code is stored in one place, then coordination between teams is very tough. So this monolithic architecture is not suitable for large size applications. Just it is suitable only for small size applications. This is all about monolithic architecture. Next I will explain what is microservice architecture in DevOps. If you consider monolithic architecture, in monolithic architecture, entire application is placed in one single folder. So changes made to one component will affect other components. But whereas in microservice architecture, your application is placed in bunch of folders. Each folder is responsible for specific function. So changes made in one folder will not affect other folders. Guys, I will give one example so that you can clearly understand what is this microservice architecture. If you consider monolithic architecture, in monolithic architecture, front-end, back-end and as well as database, all these components are stored in one single folder and they are integrated to each other. But whereas if you consider microservice architecture, in microservice architecture, each service is placed in one folder and they are not integrated to each other. As you know, there will be three components: front-end, back-end and as well as database. In front-end, I created student login form, faculty login form and as well as student attendance. So this application contains total 3 pages. For example, whenever I enter my username and password, automatically I must log into that website. So I integrated the student login form with Java code, similarly faculty login with Python code and as well as student attendance with C++ code. And I connected the student login form with separate database and as well as faculty login form with separate database and as well as student attendance with separate database. Now what I will do is, I will consider the student login form as one service and I will place this entire code in one folder. Similarly, I will consider faculty login as another service and I will place this entire code in one folder. And similarly, I will consider student attendance as one service and I will place this entire code in one folder. And these folders are not integrated to each other. So whenever I perform changes in one folder, it will not affect other folders. So whenever I perform changes in one service, it will not affect other service. For example, in student login form, I written some spelling mistake. So whenever I perform changes, it will not affect remaining folders as all these folders are not integrated to each other. For example, due to some problem in database, I cannot access student attendance. Even though if you cannot access student attendance, you can access student login form and faculty login form because all these services are placed in different folders and they are not integrated to each other. So changes made in one folder will not affect other folders and also errors in one folder will not affect other folders. This is microservice architecture. First, in front end there will be user interface and there will be multiple microservices. Each service is connected to separate database. I already explained this example. In a college website, each function like student attendance, faculty attendance, student results and college courses, all these are considered as separate services in a microservice architecture. Changes made to one service such as updating the student attendance feature won't affect the other services like faculty attendance, student results and so on. Changes made to one service will not affect other services. So this is definition. If you consider monolithic architecture, in monolithic architecture, entire application is placed in one single folder. So changes made to one component will affect other components. But whereas in microservices architecture, your application is placed in bunch of folders. Each folder is responsible for specific function. So changes made in one folder will not affect other folders. In DevOps environment, microservices architecture shines because it allows for better scalability, flexibility and faster deployment and as well as resilience. These are 4 advantages in microservice architecture. First one is scalability. Scalability is nothing but modifying one part of application will not affect other parts, such as updating student results form will not affect student attendance form and faculty attendance form. Similarly, next one is flexibility. Flexibility is nothing but teams can choose the best tools and technologies for each microservice, making it easy to adapt changing requirements. Based on user requirements, developers can update code which is present in various folders and they can easily update specific part of code because changes made in one part will not affect other parts. So they can easily modify application based on requirements. And next one is faster deployment. As we know, each microservice is independent. So you can easily update only that part of application without affecting entire application. And last advantage is resilience. If one microservice fails, it does not bring down the entire application. The rest can still function normally. For example, this faculty login is not working well. So even though if this faculty login is not working well, it will not affect student login and student attendance. This both will work normally. These are disadvantages in microservice architecture. First one is complexity. Whereas in monolithic architecture, complete data is stored in one place. So it is easy to manage application. But whereas in microservice architecture, there will be multiple microservices in different folders. So it is very hard to manage. And next one is communication. If you want to develop any application by using microservice architecture, then all employees must communicate each other efficiently. Otherwise, you cannot design good application. And third one is monitoring and debugging. As we know, each microservice is stored in one particular location. So monitoring that application and as well as finding errors in that application is very tough. These are disadvantages in microservice architecture. Next, I will explain architectural rules of thumb in DevOps. Guys, rules of thumbs are nothing but they are generally principles or guidelines widely used in a specific area. They are not strict rules, moreover like a practical suggestions to achieve positive results in system design and implementation. Guys, if you want to achieve positive results in system design and implementation, then you need to follow these principles. I will explain all these principles in detail. These are not strict rules. These rules are just suggestions. So in DevOps architecture, if you want to do good system design, then you need to follow these principles. Another first one is modularity. If you want to design any system, then you need to design system in modular fashion. Modular fashion is nothing but breaking our entire software into smaller modules that works independently. Same like microservice architecture. So maintenance and update will become easier. And next one is scalability. Scalability is nothing but if you are designing any software, even though at a time 1000 people are accessing that application must run smoothly without sacrificing performance. Third one is automation. By using various kinds of automation tools, you can automate process like deployment, testing and monitoring application. So work will complete fast and will reduce human errors. Fourth one is resilience. Resilience means building systems that can handle failures by including backup plans and automatic switches. For example, whenever your software fails, then automatically it must take backup and then it must work properly. And fifth one is infrastructure as code. Managing infrastructures like setting to track changes, recreating setups and setup automatically. Sixth one is continuous integration and continuous deployment. In DevOps, by using tool like Jenkins, you can create pipeline in order to perform automatic continuous integration and continuous deployment. Seventh one is monitoring and logging. You need to create monitoring and logging systems in order to check system performance and detect issues early. Eighth one is security. Guys, you need to integrate security practices like encryption, access control, so on in early stage of development and deployment process. Ninth one is containerization. Guys, whenever you develop any application, we will not place our application directly into server. Instead, what we will do is, we will place our application in container and then we will place this container in server. So in order to place application in container, we will use tool like Docker. 10th one is feedback loop. Development team, operations team and as well as customers, they need to communicate each other and they need to take regular feedbacks so they can develop application better. Next I will explain impact of DevOps on software quality and reliability. Guys, by following DevOps principles, you can improve software quality and as well as reliability. Reliability means software that can automatically recover from failures and work accurately. This is meaning of reliability. Next I will explain relationship between DevOps and software architecture. Guys, DevOps and software architecture both are related to each other because by following DevOps principles, you can build a software architecture. Guys, in exam they may ask separate question like explain software architectures in DevOps. Then you need to explain monolithic architecture and microservices architecture. Next question is how well-designed architecture supports DevOps principles. Guys, if you want to design high-level software architecture, then definitely you need to follow DevOps principles. Guys, for all these three questions, you need to explain this answer. These are various DevOps principles: modularity, scalability, automation, resilience, infrastructure as a service, CI/CD monitoring and logging, security, containerization and feedback loop. You need to explain all these principles. Guys, principles and practices both are same. Next I will explain separation of concerns in software architecture. Separation of concerns means dividing entire program into various sections based on their functionalities so that each section runs independently without affecting other services. Changes made in one section will not affect other sections. Guys, I will give an example so that you can clearly understand this definition. Guys, for example, I want to create College application. Let us say College application contains 4 pages: student login page, student results page, student attendance page, and as well as faculty details page. Total there are 4 pages. So instead of writing this complete code in one place, what I will do is, I will divide this complete code into 4 modules. First module contains code related to student login page, and whereas second module contains code related to student results page, third module contains code related to student attendance page, and whereas fourth module contains code related to faculty details page. I will show these 4 modules separately in different folders. So changes made in one module will not affect other modules. For example, I want to update the student results page. So without changing first module, third module and fourth module, directly I will open the second module and I will update code related to student results page. So changes made in one module will not affect other modules. For example, let us say the student attendance page is not working well. Even though student attendance page is not working well, remaining pages will work well because they are not related to each other. All are separated. So changes made in one module will not affect other modules. So separation of concerns mean dividing entire program into various sections based on their functionalities so that each section runs independently without affecting other services. Changes made in one section will not affect other sections. Guys, separation of concerns will improve maintainability. Maintainability is nothing but updating specific part of code without updating entire code. And also it will improve scalability. Scalability means we can easily update new features to that particular software. And also it will improve readability. If we store complete code in one place, then it is very hard to read. But if we separate code into various sections, then it is very easy to understand because it will look very small. And fourth one is separation of concerns will improve debugging. As complete code is separated into various sections, we can easily find and fix errors. This is meaning of debugging. I already explained this example. Just need to explain this College application example. These are some real world examples where separation of concerns is implemented. First one is model view controller architecture. MVC is classic example of separation of concerns because it divides application into 3 components. First one is model, next one is view, and next one is controller. Where model will manage data and business logic, and view handles presentation layer, and whereas controller acts as interface, that is, controller acts as middle layer between model and view. This controller will process inputs. Web applications are examples of model view controller architecture. Next example is microservices architecture. As microservices architecture also follows separation of concerns because in microservice architecture, we will break our application into various parts based on the services. As each service will perform certain tasks. E-commerce websites and applications are example of microservice architecture. And third one is client server architecture. As client server architecture is divided into 2 main components, they are client and server. So this client server architecture is example of separation of concerns. Social media applications are example of client server architecture, and whereas last one is layered architecture. Separation of concerns is implemented in this layered architecture because this layered architecture will divide application into various layers like presentation layer, application layer, business logic layer, and data access layer. Each layer has separate role, like presentation layer will handle user interface, application layer will handle business logic layer will handle business rules and logic, and data access layer will handle database. So online banking system is example of this layered architecture. These are 4 real world examples where SOC is implemented. Next I will explain how to handle database migrations in DevOps. Guys, migration is nothing but transferring something from one place to another place. And whereas database migration means transferring data from one database to another database. This process can not only include just moving the data itself, but also transforming it to fit the new database schema, updating database structure, and ensuring data integrity and consistency throughout the migration. Guys, I will give one simple example so that you can clearly understand definition. Guys, database schema is nothing but overall structure of database. For example, let us say there is college database. In this college database, there will be student table, staff table, admin staff table, and student results table and courses table and so on. For example, the student table is connected to student results table and staff table is connected to admin staff table. So this overall structure of database like tables, columns and their connections, we call this entire structure as schema. Except data, remaining everything is known as schema. For example, I created new database with name my college and I modified some tables like I inserted new columns in student table, new columns in staff table, new columns in courses table and so on. So now I want to move data from college database to my college database. But transferring data from one database to another database is very tough. It is not an easy task. Whenever you transfer data from one database to another database, then this data must fit to this new database schema. Schema is nothing but structure. This data must fit to this new database structure. So database migration is not only moving data from one database to another database, but also whenever you transfer data from one database to another database, then the data must fit to new database schema. And ensuring data integrity and consistency throughout the migration. Guys, data integrity and consistency is nothing but correctness of data. Whenever you transfer data, the data must be correct. There must not be any loss of data. In DevOps, handling database migrations means managing the process of moving data from one database to another database, while ensuring it's done smoothly without any disturbance. This is important because changes to the database structure or data need to be matched with application updates to avoid errors. Guys, whenever you update database, updating database must not affect application. If you don't update database properly, then your application will not work. So you need to update database properly in order to avoid errors. In DevOps, we'll use various kinds of techniques in order to perform database migration. That is nothing but in order to transfer data from one database to another database. And the first technique is version control. Version control is nothing but Git software. One of the essential techniques for database migration in DevOps is use of version control for both application code and the database schema. Guys, whenever you develop any application, you need to store both application code and as well as database code in Git. After storing code in Git, you will create pipeline in order to perform continuous integration and continuous deployment. Whenever you create CI/CD pipeline in order to test and deploy software, in DevOps there are various kinds of tools like Liquid-based tool and Flyway tool. You need to connect these tools with CI/CD pipeline. Whenever you connect these tools with CI/CD pipeline, whenever you update database, then automatically it will update application code. Second technique is schema migration tools. Whenever you perform database migration in DevOps, you can use schema migration tools. Example of schema migration tools are SQL Server Data Tools and MySQL Workbench. These both tools are examples of schema migration tools. Whenever you want to update database schema, that is whenever you want to update database structure, instead of modifying complete SQL code, you can modify only specific changes without modifying complete code, and rest of the code is automatically updated by using schema migration tools. So schema migration tools are used to automate making and running SQL scripts. Instead of modifying complete code manually, you can modify only specific part of code without modifying complete code. Rest everything is automatically modified by using schema migration tools. Third one is data migration tools. Schema migration tools are used to modify only schema, that is structure of database. But if you want to transfer data from one database to another database, then you can use data migration tools. For example, sometimes there will be huge amount of data in database. Manually transferring data from one database to another database is very tough. So by using data migration tools, you can automate this process. You can easily transfer data from one database to another database. AWS data migration services and as well as Azure Data Factory. These both are examples of data migration tools. Even after performing database migration, you need to test your migrated database. Like you need to check performance test, security test and so on that particular migrated database. While testing, if there are any errors, you need to fix that errors. In order to perform testing on migrated database, you can use tools like SQL test and JMeter. This is all about handling database migrations in DevOps. Next I will explain resilience in DevOps. Resilience in DevOps means the ability of system to recover quickly from problems and continue working smoothly. It ensures that services remain available even when there are issues like failures or high traffic. Guys, I will give an example. Guys, for example, if you consider Amazon website, Whenever you open Amazon website, it will be available to you. Maximum Amazon website don't get any kind of problem. Even if Amazon website get any kind of problem, it can recover very quickly within a short period of time. This is because of by following DevOps, Amazon achieved resilience. Another example is Google. Whenever you open Google search and as well as Gmail, they will be available to you. This is because Google achieved resilience by using DevOps. How organizations achieve resilience using DevOps? First one is DevOps support automation. In DevOps, each and every task is automated. Normally, human beings will not perform any kind of task. Automatically, system will perform various kinds of tasks. So, automate tasks like deployment and testing, reduce human errors and speed up recovery. So, even if any kind of error occurs, system will solve that problem instead of human beings. Second one is continuous integration and continuous deployment. Whenever developer updates small part of software, then automate testings will take place. So it is very easy to find errors and solve those errors. So regularly integrate and deploy small changes. Make it easier to find and fix issues quickly. Third one is monitoring and logging. Guys, logging is nothing but recording complete information about software. Recording each and every operation of software is known as logging. In DevOps, there are various kinds of tools available in order to continuously monitor particular software. So these softwares will constantly check those problems so that we can easily identify issues and solve a problem. Fourth one is infrastructure as a code. Hardware, software, networks, servers, databases, all this comes under infrastructure. Guys, whenever you develop any software, then you need to set hardware, you need to set database, and you need to set servers. So instead of manually setting all those things, DevOps use automation. Based on the software, by using various kinds of automation tools, DevOps will configure hardware, software, servers, database, and so on. And fifth one is microservices architecture. Microservices architecture is nothing but breaking our application into various parts based on service. Instead of storing complete code in one place, what we will do is, we will break that application into various parts based on services. So even if one service fails, remaining services will work. And sixth one is regular backups and disaster recovery plans. Guys, backup is nothing but storing multiple copies of our data. So even if data loss occur, we can easily restore the data. And also we need to prepare various kinds of plans in order to recover from major failures. And seventh one is scalability. Scalability means designing system that will handle high load automatically. Guys, there are three popular companies using DevOps in order to build resilient architecture. And the first one is Netflix. Netflix use automation, continuous integration and deployment, and as well as microservices architecture. Netflix company use one tool called Kiosk Monkey. By using this Kiosk Monkey tool, Netflix wantedly tries to fail application and it will check whether application is causing failure or not. This is how Netflix built resilient architecture. And second one is Amazon. Amazon use automation and as well as infrastructure as a code and as well as scalability. Scalability is nothing but designing system to handle high load automatically. So even during high traffic periods, Amazon will be available to you. For example, if you consider festival seasons like Amazon Great Indian Festival, during that festival seasons, millions of people will access Amazon. Even during high traffic period, Amazon will be available to you. And third one is Google. Google utilizes monitoring, logging, and as well as automated recovery. So that is why Google services like Google Search and as well as Gmail are highly available. These are three companies using DevOps for building resilient architecture. Next, I will start Unit 3. I will explain each and every topic in detail. At first, I will explain what is need of source code control. But before starting this, you need to know what is source code control. Guys, we also call this source code control as version control. Source code control is a system that helps you to manage and store your files, particularly the code you write. Guys, source code control is nothing but it is a software. In that software, we can store our files and as well as we can manage our files. That is nothing but we can modify our files, we can update our files, we can delete our files and so on. We can perform various operations on that files. So source code control is nothing but it is a software. In that software, we can store our files and as well as we can manage our files. Mainly this source code control is used by developers in order to store their code. Whenever developer write any code, he will store that code in source code control. Later on, he will perform various operations on that code. In DevOps, we will use two kinds of tools for source code control. They are Git and GitHub. Guys, for example, I am developer. I written code. In DevOps, whenever developer write code, at first he will place that code in Git software. Git is nothing but Git is a software that is present in your system. So whenever developer plays that code in Git software, only this developer can access that code. Remaining employees cannot access that code. If all remaining employees want to access this code, then this developer need to send this code to GitHub. So from Git, this developer will send code to GitHub. GitHub is nothing but it is a website. So at first developer will write code and he will send that code to Git. Git is nothing but it is a software that is present in your system. Only this developer can access this code. Remaining employees cannot access this code. So if all remaining employees want to access this code, then you need to place this code from Git to GitHub. GitHub is nothing but it is a cloud-based website. So whenever developer places that code in GitHub, all remaining employees can access that code. And all these employees can perform various operations on that code. This is all about Git and GitHub. Git is a software tool that can be used locally on your computer. You can create a local repository on your computer where you can store and manage your code. Guys, repository is nothing but it is a place where we will store all our files. So in your computer, you can create a local repository and you can store all your files in that repository. GitHub is a web-based platform that allows you to store your Git repositories in the cloud. By writing small lines of commands, you can easily transfer your data from Git to GitHub. Whenever you place your files in GitHub, all remaining employees in your project can access those files. So multiple people can work on the same project, submit changes, review code and manage projects. They can perform various modifications on your files. Guys, there is an American author. His name is Terence McKenna. He passed one statement. That is, he said that everything is a code. But whether you believe that or not, in DevOps almost everything is a code. Almost many parts of work can be described, managed and automated using code. For example, I want to create application. So for that purpose, I need to write code. So in DevOps, after creating application, you need to set up infrastructure. That is nothing but you need to set up servers and as well as network in order to place our application. So in order to automatically configure our server and network, again you need to write code. In DevOps, we will use code in order to automatically configure our servers and networks based on our application. So in DevOps, we will not create documents manually. We will also automate documentation process by writing code. And in order to run our application, we need to set up hardware. Even for this, again we need to use code in order to automate this process. So in order to create application and in order to set up infrastructure, that is nothing but in order to automatically set up servers and networks, we will write code. In order to create documentation, we will use code. And in order to set up hardware, we will use code. So whatever Terence McKenna said is correct. In DevOps, almost everything is a code. Next, I will explain why we need source code control. Guys, the source code control acts as central storage. That is nothing but all our code, scripts and documentations. All are kept in one place. So we can easily find and manage those files. Second one is teamwork. Whenever you place your code in source code control, all developers can work together on that same code. For example, GitHub is example of source code control. So whenever I write code and place that code in GitHub, all remaining employees can work on that same code. For example, this developer modified my code. So immediately GitHub will store those changes. So immediately GitHub will store who made changes, when they made changes and what changes they made. So by using source code control, teamwork is possible. Developer can work together on same code. The source code control keeps track of changes made by different people. Third one is tracking changes. I already said before, whenever any developer performs changes, every change is saved. It will store who made changes, when they made changes and what changes they made. Everything is stored. And if there is any problem, then we can go back to early version of code. Fourth one is backup. The source code control acts as backup. For example, if you consider GitHub website, it is cloud-based website. So even if there is any damage to your system, you can easily restore our data because our data is present in cloud. So even if there is any damage to your system, you can easily restore our data because our data is present in cloud-based website. Fifth one is history. If any developer perform modifications on our code, then we can easily see who made changes, when they made changes, and at what time they made changes and so on. So we can see who made changes and when they made changes. So this helps us to understand why changes were made and finding bugs. So we can easily find errors. And sixth one is consistency. Guys, meaning of consistency is correctness. Repository is nothing but it is a place where our complete data is stored. As all developers are using only one repository, everything will be correct. Seventh one is deployment. Guys, in DevOps everything is automated. So whenever developer perform any modifications on code, automatically testing is performed on that code and then that code is placed in server. So in DevOps this process is automated. So releasing newer versions of software is very easy. So in DevOps source code control is very important because source code control is a place where we will store our entire project. So in source code control, as complete project is present in one place, all employees can easily access and manage that project. Without source code control, managing our project is very difficult. So good source code control is very important for success in DevOps. Next I will explain history of source code management. If you understand history of source code management, then you will get to know why it is important today. These are some of the important points. First one is storing older versions of code. Guys, in olden days, if people want to store their older versions of code, then they used to store them in separate files or archives. This method is very simple and useful. For example, I am developer. I developed code. So I will store this code in separate file and later on I updated this code. So again I will store this updated version in another file. So again I will update and again I will store this code in separate file. Like that people kept older version of their code in separate files. And later on they used centralized source code management with check in and check out. Guys, centralized source code management is nothing but our complete code is stored in one particular location. So only one employee can access that code at a time. So while one employee is accessing that code, remaining employees cannot access that code. For example, this is centralized source code management tool. Total there are 4 developers. Now this developer want to modify this code. Whenever this developer want to modify this code, then he will log this file. If this developer log this file, remaining employees cannot access this file at the same time. For example, now this developer want to access this file. If this developer want to access this file, then this developer must release that lock. Only if this developer release that lock, remaining employees can access that file. This is all about centralized source code management. In some systems, a developer could lock a file to work on it alone. So no other else could change it at the same time. Each file was managed separately. Guys, there are 2 tools. One is RCS, stands for Revision Control System, and another one is SCCS, stands for Source Code Control System. But nowadays no one are using this, these are outdated. After that, later on people used centralized store with merging before committing. Guys, centralized store is nothing but where our complete code is kept in one place. I will give one example. For example, this is centralized store. I am developer. I return code and I will place that code in centralized store. After placing my code, I will perform commit operation. Guys, commit is nothing but saving that code permanently. So once if I perform commit operation, this code is permanently stored in centralized store. For example, now there is another developer. This developer want to update this code. So he will take this code and he will update that code. So now we will merge this code with existing code. After merging this code, he will perform commit operation. That is nothing but now this code is stored permanently in centralized store. Guys, there are 2 types of tools. They are concurrent version system and as well as subversion system. If you are using these 2 types of tools, then you need to merge changes before you commit them. If I update any code, then I need to commit that code. Only if you commit that code, then the changes are permanently stored. Concurrent version system is outdated, but subversion is still used by many of the companies. Now at present, most of them are using decentralized source code management. The name itself says decentralized. That means our complete code is not stored in only single place. I will give an example. Guys, centralized means our complete code is present in one single location. So if any employee want to work with that code, then he need to work from here itself. And whereas decentralized means developer will not work in the centralized location. What developer will do is developer will work in his own system. Guys, I will give one simple example of centralized and decentralized. For example, there is a library. If you want to read books, then you will go to library. Similarly, if your friend want to read books, he will go to library. Different people are going to library. So we call this library as centralized. For example, I want to read books. I have my own library in my house. Similarly, my friend want to read books. Then he has his own library in his house. So each person has personal library in his house. So we call it as decentralized. Similarly, if all developers place their code in one single server, then we call it as centralized. Similarly, each developer has full code on their computer and they will perform various operations on that particular code in their system itself and they will communicate each other. We call it as decentralized. Git software is one of the example. Decentralized source code management allows for more flexibility and faster workflow. The most popular tool in this category is Git. Not only Git tool, there are some other tools like Bazaar and Mercurial. Decentralized tools are very powerful, but they can also be risky if you don't use carefully. These are some of the key points. First one is most popular decentralized tool is Git. And second point is by using these decentralized tools, people can work better way and collaborate better. And next point is these decentralized tools are more powerful and flexible. As they are more powerful, if you don't use them properly, then there is high chance for mistakes. In olden days, people used to store their data in files. But at present, people are using decentralized source code management in order to store their files. So by seeing this, you can clearly understand how technology is improving day by day, from storing data in files to storing data in decentralized tools. Next, I will explain roles and code in DevOps. Guys, in DevOps, source code management tools like Git and GitHub are very important because by using these tools, all team members can communicate each other and they can work together smoothly. Guys, in DevOps, there are various kinds of employees use these tools. And the first one is developers. Daily developers will write code, and whatever the code that these developers write, they will store that code in Git. So developers use source code management every day to do their coding work. And next one is operations team. Before placing our software in server, at first we need to configure that server and also we need to configure network. So operations team also depends on source code management in order to set up networks and also in order to configure servers. In order to set up servers and networks, they will write code and that code is stored in Git. And also QA team, that is nothing but testing team, also use Git. This QA team will store code related to testing in Git. And in order to automatically perform testing, they will use tools like Selenium and JUnit. So even testing team also use Git in order to store code related to testing. And last role is project management. Guys, these project managers will not use source code management like Git softwares because they don't have any idea when compared to technical team. Only technical team will use source code management tools. Guys, for example, if you want to develop any software, then we need to write steps. In olden days, software employees used to create Word documents or they use emails in order to store steps related to develop software. And they used to store that information in Word files or Gmails in order to write complete steps to develop software. But if you store documentation in Word files or Gmails, then it is very hard to find. This wikis tool is example of source code management. Whenever software employees write documentation, they used to store their documents in wiki software. So if you store documents in wiki software, then it is very easy to find those documents. So these are various roles use source code management softwares like Git in order to store their code. So source code management tools are very important for many roles in DevOps. So developers, operations team, testing team depends on source code management tools in order to smoothly complete their work. Project managers don't have any idea about these tools. So even to store documents, people depends on source code management tools like wikis. So if you store all documents related to company in one place, it is very easy to find those documents. So by using different source code management tools, companies can work better. Next I will explain source code management system and migrations. Guys, there are many source code management systems and they are very important for software development because whenever any developer write code, at first he will store that code in source code management system. And Git software is one of the most popular source code management system. Guys, Git software has an interesting history. This Git software was created by Linus Torvalds. He created this Git software because in olden days, Linux developers used a tool called BitKeeper in order to manage their code. This bitkeeper was a good tool, but whenever its license changed, they cannot use complete features of this bitkeeper anymore. If they want to use complete features of this bitkeeper, they need to pay money. So instead of paying money to this bitkeeper software, Linus Torvalds decided to create a new tool. The tool name is Git. This Git was mainly created in order to manage code written by developers. Whenever developer write any code, at first he will place that code in Git. Guys, when compared to older systems, Git software has one of the major advantage, that is, Git is distributed version control system. That means there is no central server in order to store files. Each developer will work independently by sharing code among themselves. Guys, there are many distributed version control systems available. But among all these distributed version control systems, Git is one of the famous tool. These are benefits of Git software. First one is, you can use Git offline. There is no need of internet in order to use this Git software. And there is no need of connecting to server for each and every operation. So Git is very fast. Guys, this Git software is present in your system. So only you can access the software. No others can access that software. So all your files are secure and private. Only if you share that code in GitHub, so all employees can access. So until that, your Git software is private and secure. Guys, for example, you are developing project. Then you can share multiple copies of your project in different locations in Git software. So unexpectedly, if you delete one copy of your file, still remaining copies are available. So if you use Git software, then there is no loss of data. And this Git software is open source. That is nothing but you can download this Git software with free of cost in internet. And services like GitHub, GitLab, Bitbucket, all this supports Git. Guys, not only Git, there are some other distributed version control systems. They are Bazaar and Mercurial. Guys, Git is very complex because if you want to use Git software, then you need to learn Git commands. Even though this Git is complex, it is very fast and efficient. So if you don't know Git commands, if it is hard to understand, then you can also use graphical frontends in order to use Git software. Guys, migrations mean transferring something from one place to another place. And whereas source code management systems migration mean moving data from one source code management system to another source code management system. After working with many source code management systems, there are some situations where you need to transfer your data from one source code management system to another source code management system. Moving data from one source code management system to another can be simple or it can be complicated based on source code management systems like Git, Subversion, Bazaar, etc. For example, if you want to transfer data from Subversion to Git, then it is very easy. But if you want to transfer data from Git to Bazaar, it can be very tough. So depending on systems, moving data from one source code management system to another can be either complicated or it may be simple. And for many projects, keeping history is not necessary because still if needed, you can access old system data. Guys, Git, Subversion, Mercurial, Preforce and Bazaar, all these tools are examples of source code management systems. And I already said before, moving data from Subversion to Git is very easy and there is no loss of data. Still data will be accurate. Guys, next topic is shared authentication. Authentication is nothing but verifying user. I'll give one simple example. For example, I'm user. I want to use Facebook. Only if I enter correct username and correct password, I can access Facebook. What if I enter wrong password? I cannot access Facebook. So authentication is nothing but verifying user, whether this user is correct user or wrong user. If he is correct user, then he can access website. And if he is wrong user, then he cannot access website. In many organizations, there is a central server that handles authentication, which verifies and allows access for users. One common type of central authentication server is an LDAP server, where LDAP stands for Lightweight Directory Access Protocol. Guys, many companies are using LDAP server in order to verify users. That is in order to check whether this user is right user or wrong user. If he is right user, then this LDAP server will give access to that user, and if he is wrong user, then this LDAP server will not give access to this user. If your organization is already using LDAP server, then it is very easy to manage user authentication. That is nothing but it is very easy to verify users. Even if your company is not using LDAP server, then creating one dummy LDAP server is very easy. We call this dummy LDAP server as test LDAP server. In order to create one dummy LDAP server, you need to install one software in your system. That software name is 389 server, and also you need to install one web application. That web application name is PHP LDAP admin. By installing these two softwares, you can create one dummy LDAP server, and this dummy LDAP server will work same as original LDAP server. Guys, if you want to learn this LDAP server, then at first you need to install one dummy LDAP server in your system by installing these two softwares, and you can see how authentication will work without affecting your main system. And if you want to verify user authentication for different servers, then you need to follow the same process. This is all about shared authentication. Next topic is hosted Git servers. Guys, GitHub website and GitLab website. These both are examples of hosted Git servers. But many companies are not using these hosted Git services like GitHub and GitLab because of some legal reasons and because of some security issues. This GitHub and GitLab, these both are websites that are available in internet. So there is high chance of hacking. That is why many companies will not show data in GitHub and GitLab websites. For example, if you consider government organizations or companies dealing with money, for example, if you consider government, banks and insurance companies, they will not store their code in GitHub or GitLab because GitHub and GitLab are cloud based that are present in internet. So because of some legal reasons and security issues, they will store their code in their own systems. For example, I have a company. I want to store my code in hosted Git servers like GitHub and GitLab. So if you don't have any problem, then storing your code in GitHub or GitLab is very convenient. And you can easily create free account in both GitHub and GitLab. So simply you can create free account and you can see what they offer. And this GitHub and GitLab provides various kinds of features such as web interfaces, documentation wiki, issue tracker, commit and branch visualization, pull request workflow. These are various features offered by both GitHub and GitLab. Guys, this Git is software maintained by Linux. And whereas GitHub is product that belongs to Microsoft and GitLab is product that belongs to GitLab company. For example, I'm developer. I'm developing code in my system. Whenever I develop code, at first I will place my code in Git software. Whenever you place your code in Git software, only you can access that code. Remaining employees cannot access that code. If all remaining employees want to access that code, then you need to place that code in GitHub, where GitHub is cloud-based website. Guys, GitHub and GitLab both are same, but they belong to different companies. Guys, Git software is mainly designed in order to store text files. But if you want to store large size binary files like images, audios, videos in Git software, then your Git software will become slow and it will decrease performance. So if you want to store large binary files like images, audios, videos, then you can use GitHub and GitLab. Guys, there are mainly two tools that we can use in order to handle large size binary files. They are gitlfs and gitnx. By using these two tools, you can handle large binary files. gitlfs, where LFS stands for large file storage. This gitlfs is supported by GitHub and gitnx is supported by GitLab. We cannot use this gitnx in free version of GitLab. Only you need to pay money and you need to use GitLab Enterprise Edition. Next I will explain different Git server implementations. Guys, whenever you develop any project, at first we will store our project in Git software. From Git software, we will copy our project into various servers like GitHub, GitLab and Bitbucket. From Git, in order to copy our project into various servers, you need to use same Git commands. For example, if you want to copy your project from Git to GitHub, you need to write same Git commands. And similarly, if you want to copy your project from Git to GitLab, you need to write same Git commands. So, if you want to copy your project from Git to various servers, you need to use same Git commands. There is no change. And each server has different features and benefits. And you can also work with all the servers at a time. Git is a system that allows you to work with multiple copies of your project. These copies can be on different servers like GitHub, GitLab, Bitbucket, etc. to see which one is best for you. Each server might have different features or benefits. No matter which server you choose, the way you use Git on your computer will be the same. You need to use same Git commands and tools for different servers. You can work with more than one Git server at the same time. For example, you can store same project in GitHub and as well as in GitLab. And by using Git software, we can connect to different servers like GitHub, GitLab, Bitbucket, etc. This is all about different Git server implementations. Next I will explain what is Docker intermission. Docker is a tool that makes easy to package and run applications. Guys, Docker is nothing but it is a software. By using Docker software, we can easily package our application and run our application. Docker helps us test different Git server implementations like GitHub, GitLab, Bitbucket, etc. without much struggle. Guys, I will give an example. By using Docker software, we can test different Git servers. For example, I am using Docker software. My project is present in GitHub, my project is present in GitLab, and my project is present in Bitbucket. By using Docker software, we can easily connect to these servers and then we can create package and then we can run that project. As Docker packages your application into a container, so your application will run same way on different systems like laptops, desktops, virtual machines, physical servers, etc. And in Docker software, there will be Docker container. So whenever we place our project in container, all users can access that application. For example, one user is using desktop, another one is using laptop, and another one is using physical server, etc. Either it can be any system, our application will work because we are packaging our application and then we are placing that application in container. So whatever system you use, there will not be any problem. Docker containers run independently, so you can test different setups without interfering with others. Guys, in Docker software, there will be multiple containers and in each container, we can place one project. And this container is not dependent on this container. Similarly, this container will not depend on this container. So each container will work independently. Guys, in order to install Docker in Red Hat based systems, you need to use this command dnf install docker-io. And in order to enable Docker, you need to use this command systemctl enable docker. And in order to start Docker software, you need to use this command systemctl start docker. Guys, there is also another tool called Docker Compose. By using this tool, we can run multiple Docker applications together. Next, I will explain what is Gerrit. For example, let us say there are 4 developers who are developing college application. Each developer will write code in his own system and there is GitHub server. In that GitHub server, there is main code base. Main code base is nothing but it is a place where complete project code is stored. Whenever we place code in main code base, automatically this code is tested and then this code is placed in server. But whenever developer write code, they are not going to place complete code directly into GitHub. Before that, whenever developer write code, at first that code is reviewed by senior developers in order to check whether that code is correct or not. Only if that code is correct, then that code is placed in main code base. So whenever developer write code, at first he will send that code into Gerrit software. In that Gerrit software, senior developers will review that code. Only if that code is correct, the changes are reflected into main code base, which is present in GitHub server. So Gerrit is a place where developers will submit their code for review. Gerrit is a tool for reviewing and approving code changes before they are merged into main code base. Whenever any developer makes changes in code, that code changes are reviewed by experienced developer before they are merged into main code base. Gerrit is a platform where developers can submit their code changes for review. This ensures that only well-reviewed and high-quality code modifications are integrated into project. Next, I will explain benefits of Gerrit. First one is control who can review and approve changes. Guys, each and every developer will not review code. Only experienced developers will review code. So, by using Gerrit software, we can give only permissions to senior developers. Only they can review code. Remaining employees cannot review code. And next benefit is ensure that only reviewed and approved changes are merged. Only if senior developer accept that code, then that code changes are placed in main code base. Guys, we can run Gerrit by using Docker software. So for that purpose, you need to use this Docker command in order to start Gerrit. Docker run -d-p 8080:8080 -p 29418:29418 and here you need to give image file location. This Docker run command is used in order to start new container that will store this Gerrit image, where -d stands for detached mode that will run in background and -p stands for port number. In this port number, our application will run. And in order to access Gerrit, you need to open any web browser and go to this URL Next I will explain what is pull request model. The pull request model is a way of merging code changes where developers make changes in their own copies of repository and then they will request to merge changes into main repository. Guys, I will give an example. Guys, for example, I'm developer. For example, in GitHub website, in main branch, there is complete code related to call a website. Now I want to do some modifications in this code. So, as a developer, I will download this complete code and then I will modify that code in my system. And after modifying code, I will send this modified code to repository owner. Directly I cannot place this code inside this main branch. I will send my pull request to repository owner. Only if this repository owner accepts my pull request, then my code will be placed in main branch. Pull request model is a simple process that is widely used, especially in open source projects. Repository owners can review and approve changes before they are merged. If any developer want to place code in main branch in GitHub website, only if this repository owner accept my request, only then my code will be placed in GitHub website. These are benefits of pull request model. First benefit is encouraging collaboration by allowing multiple people to work on the same project. Guys, multiple people can work on the same project in their own system and they will send pull request to repository owner in order to place that code in main branch. Only if that repository owner accept, only then that code will be placed on main branch. And next advantage is my code will be reviewed by repository owner. So only quality code will be placed in GitHub. Next I will explain what is GitLab. GitLab is a platform that helps software teams manage their project from starting to finish. Guys, in GitLab, you can store your project and as well as you can manage your project from starting to till finish of your project. It's like a toolbox that includes everything the developers needs. Guys, GitLab can store Git repositories. Repository is nothing but it is a place where your project is stored. GitLab will store your project and as well as GitLab will manage your project using Git software. Guys, whenever any developer makes changes in GitLab, then GitLab will store who made changes and when they made changes. And multiple people can work with GitLab at the same time without any problem. And next one is continuous integration, continuous deployment. Guys, whenever any developer places code in GitLab, then automatically testing is performed on that code and automatically that code is placed in server. And third one is code reviews. Guys, by using GitLab, we can also review code. That is nothing but we can check whether code is correct or wrong. And next one is issue tracking. Guys, for example, if there are any bugs or if any task is pending, then automatically GitLab will give notifications. And next one is wiki and documentation. Guys, by using GitLab, we can store documents in separate location and also we can share the documents. And sixth one is security. Guys, GitLab is very secure. No one can hack GitLab. And next one is integration with other tools. Guys, we can also integrate GitLab with other tools like monitoring tools, testing tools, deployment tools and so on. Next I will start unit 4. I will explain each and every topic in detail. At first I will explain what are build systems. Guys, build system is nothing but it is a software. By using this software, we can compile code and also we can test that code. If compiling and testing is successful, then it will package that code. That is nothing but it will create one executable file. Directly we can place that executable file in server. Placing our executable file in server is known as deployment. So build system is nothing but it is a software that can compile and test code to verify code is working correctly or not, and then it will package that code, that is it will create an executable file for deployment. So build system is nothing but it is a software that will perform 3 operations. One is compiling code, next one is testing code and next one is packaging that code. That is nothing but it will create one executable file. Guys, there are many build systems that have been created for software development, and also sometimes you may feel like there are more build systems when compared to programming language. These are some of the example. For example, for Java code, you can use build systems like Maven, Gradle and Ant. For C and C++ code, you can use build system like Make, and for Clojure programming, you can use build systems like Langingen, Boat and Maven. And for JavaScripts, you can use Grunt. For Scala, you can use SBT. For Ruby, you can use Rake tool. And for shell scripting, you can use various kinds of build systems based on your needs. Guys, all these are build systems. That is nothing but all these are softwares. By using these softwares, we can compile code, we can test code and as well as we can package that code. That is nothing but we can create one executable file. By using all these build systems, we can perform these operations. Depending on your company and type of software that you are creating, you need to choose softwares. And some companies are creating their own build softwares. Normally, many companies will use only one build system for all projects, but it is not right because, for example, let us say one company is using Maven software for all projects, but it is not right because Maven is suitable only for Java projects. It is not suitable for Ruby projects and JavaScript projects. For JavaScript, Grunt software will be best, and for Ruby, Rake software will be best. So, based on your project, you can choose different build systems. You should not depend only on one build system. As a developer, whenever you write code, at first you need to build that code in your own system. If build process is successful in your system, then you can place that code in GitHub. So all remaining employees can access that code. So as a developer, at first you need to build code in your own system. For example, let us say you are a developer, you are developing one project. That project contains code related to Java and as well as JavaScript. So now you need to build both Java code and as well as JavaScript code. In order to build Java code, you need to use Maven, and in order to build JavaScript, you need to use Grunt. So now what we can do is, now we can combine these two softwares and you can use in order to build your project. Combining these two softwares makes your work easy. So if you have to support multiple build systems, you can combine them. This makes things simpler and allows different build systems to work together. For example, one company wants to build a Java project. Then in their system, they need to run this command in order to build Java project, mvn clean install, where mvn stands for Maven. Whenever you run this command, at first it will compile Java code, and then it will test Java code, and then it will save executable file in your system. Next I will explain what is Jenkins build server. Guys, build system is nothing but it is a software, and whereas build server means it is a computer, that is it is a system. If you want to build any project, then you need to install build system software in your build server. So build server is a machine, that is it is a computer that runs the build process automatically. Build server uses the build system software to compile code, to test code, and as well as to create executable files. So one of the popular build server is Jenkins, and this Jenkins is written in Java. As in olden days before Jenkins, companies used one server called Hudson. Oracle company took this Hudson. In that company, there is one creator called Koshuk Kawaguchi. This person modified Hudson server and then he gave new name. That new name is Jenkins. So this Jenkins server is updated version of Hudson server. And today Jenkins is more popular than Hudson. Jenkins is famous for building Java projects. Guys, not only Java projects, you can also build softwares made by other programming languages. Guys, installing Jenkins server in your system is very easy. For example, let us say I am using Ubuntu operating system. Then you need to run this command in order to install Jenkins, that is sudo apt-get install Jenkins. Whenever you run this command in your system, you can install Jenkins. And in order to start Jenkins service, you need to run this command sudo systemctl start Jenkins. Whenever you run this command, it will start Jenkins. And in order to access Jenkins, you need to open your web browser and you need to type this URL, that is http://localhost:8080. You can access Jenkins in this URL. And in order to see status of Jenkins, that is, in order to check whether Jenkins is active or not, you need to run this command sudo systemctl status Jenkins. Whenever you run this command, you can see status of Jenkins. In Jenkins, work is organized into jobs. Jobs can perform various tasks like compiling code, testing code, and deploying application and so on. Guys, in Jenkins, we don't call work as task, we call work as job. For example, let us say I want to compile code and I want to test that code. So we call it as job. Guys, in Jenkins, we can automatically compile code, test code, and we can deploy code. I will give an example. Let us say I am a developer. I developed a project and then I will place that project in GitHub. Now what I will do is, I will connect this GitHub website with Jenkins. So whenever any developer places code in GitHub, automatically Jenkins will take that code. Then Jenkins will automatically compile code, test that code, and then automatically Jenkins will place that code in server. So in Jenkins, we can automate jobs. For example, let us say there is another developer. He modified my project. Whenever he modified my project, automatically again this code is compiled, this code is tested, and this code is placed in server. Jenkins is especially used for continuous integration and continuous delivery pipelines. It ensures the software is quality and efficient. Guys, continuous integration is nothing but compiling code, testing code, and then creating one executable file is known as continuous integration. And continuous deployment is nothing but placing our executable code in server is known as continuous deployment. So this entire pipeline is created by using Jenkins. Next topic is Jenkins plugins. Guys, there are so many plugins that you can install in this Jenkins server. Directly you need to open this Jenkins website and then you can install all plugins in that website. And some plugins can be installed even without restarting Jenkins. And one of the popular plugin is Git plugin. So from Git, Jenkins will automatically pull that code and then it will perform various operations like compiling code, testing code, etc. Among other plugins, we need the Git plugin to pull our source code. Guys, these are some of the popular plugins that you can install in your Jenkins server. First one is Git plugin. By using this plugin, you can pull code. And next one is Maven plugin. By using this Maven plugin, you can build Java projects. And next one is JUnit plugin. By using this JUnit plugin, you can perform unit test. And next one is Selenium plugin. By using this Selenium plugin, you can perform integration test. And next one is Docker plugin. By using this Docker plugin, you can place your application in containers. These are some of the popular plugins that you can install in Jenkins server. Next topic is managing build dependencies. Guys, whenever you develop any project, you cannot directly build and run that project. Before that, whenever any developer develop project, along with this project, you need to add some more files in that project in order to build and run that project. We call these files as dependencies. Only if dependencies are present, then we can successfully build and run that project, or else we cannot build and run that project. Build dependencies in simple terms refer to the other software components or files that your application needs in order to successfully build and run your application. Some build systems like Maven for Java and Grunt for JavaScript automatically create dependencies like POM XML file based on your projects. Guys, some build systems like Maven and as well as Grunt. These both softwares can automatically create dependencies based on your project. And for example, for C and C++ projects, there are some tools like GNU auto tools and auto config tools. What these tools will do is, instead of separately creating dependencies, already some dependencies are present in these tools. So these dependencies are automatically added to C and C++ projects. Whereas Maven tool will create dependencies based on project, and whereas GNU auto tools and auto config tools, these tools already contain some dependencies. These dependencies are automatically added to all projects. Guys, in software development, whenever you want to develop any software, then you need to have clear idea about features of the software. For example, let us say I want college application. Then you need to know all features of that application, like in that college application there must be student login form, faculty login form, student attendance, faculty attendance, and so on. So whenever you develop any project, you need to know all features of that project. After placing your software in server, if you miss any feature, then it will be very tough to modify entire code again. Guys, for example, let us say I am developing project, but I don't know what are the dependencies that are required for that project. So if you don't know dependencies required for your project, then you can use some tools like RPM, where RPM stands for Red Hat Package Manager. Whenever you upload your project into RPM, RPM will automatically provide what are the dependencies that are required for your project. Based on that, you can create dependencies. Next, I will explain what is file system layout. In DevOps, the file system layout refers to how files and directories are organized on servers or systems and managed within DevOps environment. Guys, file system layout is nothing but how files and directories are organized on servers. Directories are nothing but folders. In order to successfully build and deploy our software, definitely we need to arrange all files and folders in proper format. So arranging files and folders in proper format is known as file system layout. This includes, first one is application deployment structure. Guys, in server, we need to arrange our application and the dependencies in proper organized format in order to deploy our application. If you don't arrange your application and dependencies in proper format, then we cannot successfully deploy our application. Second one is configuration management. Guys, there are some configuration files like YAML file, JSON file, etc. By using these files, we can configure our server. So we need to arrange these files in proper format. And third one is version control. Version control is nothing but Git. In Git software, We need to store our code files in organized format. And fourth one is artifact repositories. Guys, whenever you develop any software, then we need to build and test that software. So after building and testing is successful, then artifact will be generated. So we need to store these files in organized format in repositories. Guys, if you follow proper file system layout, then it is very easy to develop, test and deploy your software. Next topic is the host server. Guys, duty of build server is to create software. So after creating your software successfully, we need to place that software in host server. So whenever you place your software on host server, all users can access the software. So duty of build server is to create software, and whereas host server focus on running the software. So once application is placed in host server, all users can access that application. So in any company, build server is very important. While building software, build server will consume lot of processing power, memory and disk space. That is why whenever you purchase any build server, you need to purchase only high quality build servers that has high disk space and RAM. Different employees will write code and they will place that code in build server. So definitely build server must be fast. As we know, machines are cheaper than people. That is why we need to invest your money on good machines. Next topic is build slaves. Jenkins is one of the popular build server. Jenkins will build code. And in order to complete build process very fast, we can connect Jenkins server with other servers. We call these servers as build slaves. Different slaves contain different operating systems. So based on needs, Jenkins server will send tasks to any of these servers. Guys, we can connect your slaves with Jenkins by using three ways. First one is by using SSH, and second way is you need to install Jenkins software in your build slave. Next way to connect your build slave with Jenkins server is by installing Java client in your build slave. These are three ways by which you can connect your build slave with Jenkins server. To make build process faster in Jenkins, you can add extra servers called build slaves. The main server sends a task to the slaves either in a round robin way or based on specific needs. Guys, Jenkins server will send a task in round robin way like it first to this server, next to this server, next to this server, and again first server, second server and so on. For example, Jenkins server want to perform task on Windows computer. At that time, directly Jenkins server will send task to slave 2. So task is shared either in round robin way or based on specific needs. So some tasks need only particular operating system. So having different build slaves is very important. You need to launch some task only on Linux operating system. At the time we cannot use Mac operating system or Windows operating system. Guys, you can run various tasks on different build slaves at a time. Guys, for example, let us say you are developing an Apple project. Now you need to build an Apple project. But by using virtual server, we cannot build Apple projects. At that time directly you can use Mac slave in order to build Mac projects. So based on your project, Jenkins server will send project to different build slaves in order to build your project. There are several ways to connect build slaves to master. One common method is using SSH or by using Jenkins software, and another method is by downloading Java client in your slave. If slave don't support SSH, then directly you can use Java client. Guys, sometimes you can also use Linux servers in order to build software related to Windows. At that time, you need to install cross compilers in your Linux operating system like GCC with MinGW. Whenever you install this in your Linux server, you can easily build Windows softwares in Linux server. Guys, companies like telecom and banks use system code. By using this system code, you can build various kinds of application in only one server without using different kinds of servers. Guys, each and every company has different needs and you need to set up your environment based on that needs. Next topic is software on the host. Guys, if you want to build any software, then you need to install various kinds of tools in your build server. As we know, Jenkins is one of the popular build server. But actually Jenkins server will not perform any build operations. In Jenkins server, there are various built-in tools. These tools will perform build process. Guys, whenever you are using any build server, definitely we need to install Linux operating system in that server. And by using internet, you can install various kinds of tools in that server. And whatever steps you follow to update application server, same steps you need to follow in order to update build server. Next I will explain what are triggers. Guys, trigger is like a start button that begins an action automatically based on certain conditions or events. For example, I clicked on mouse, so some action will take place. I clicked enter button on my keyboard, so some action will take place. So clicking on mouse, clicking on keyboard, all these are examples of triggers. At first I will explain what are scheduled builds. Guys, whenever you develop any code, at first we need to compile that code and then we need to test that code. After testing is successful, then one artifact will be generated. So compiling code, testing code, and as well as generating artifact. All this comes under build process. Guys, for example, let us say every day at morning 6 o'clock, I need to perform build process on my server. This is example of scheduled builds. You can set a timer to run builds at specific time, like every hour, every day. This ensures builds happen regularly. Next one is polling for changes. Guys, whenever any developer write code, at first he will place that code in Git software. From Git, he will place that code in GitHub. So whenever developer places code in GitHub, automatically Jenkins server will start build process. For example, another developer modified code in GitHub. So whenever any developer modify code in GitHub, automatically Jenkins server will start build process. So Jenkins can check your code repository like Git for updates. If changes are found, then Jenkins will start build process automatically. So only latest code will be in server. And third one is nightly builds. Guys, normally for some kind of projects, if you start build process at morning, it will take lot of time to complete that build process. So in order to save your time, you can start build process at night time, so that it will save your time. So night builds are scheduled builds that runs at night, usually when no one is actively working. These night builds take lot of time, so employees can check it in next working day. And fourth one is upstream and downstream builds. Guys, normally in Jenkins server, we will perform different kinds of jobs one after another. For example, let us say, total I want to perform 4 jobs on my Jenkins server. First job is to check code, next job is to build code, next job is to test code, and next job is to deploy code. So one job is connected to another job. Whenever one job is successful, then automatically Jenkins server will start next job. For example, I am unable to complete job 2. So whenever any job is unsuccessful, then it will not go to next jobs. When one job finishes successfully, it can trigger to another job. For example, job 1 is completed successfully. Then we call this job 1 as upstream. Now it will perform second job. So we call this second job as downstream. So in Jenkins, by using triggers, we can automate build process. So that by using triggers, your software is built and tested successfully. Next topic is job changing and build pipelines. Guys, in Jenkins, job chaining is nothing but connecting jobs. So that whenever one job finishes successfully, then automatically it will start next job. So one job depends on another job, like job 2 depends on job 1, job 3 depends on job 2. Similarly, job 4 depends on job 3. For example, I am unable to complete job 2. So if job 2 is unsuccessful, then it will not go to job 3. I completed job 1. So we call this job 1 as upstream. Now it will go to job 2. So we call this job 2 as downstream. The first job in the sequence is called upstream build and next one is called downstream build. Guys, by using job chaining, we can complete multiple tasks. And there is also complex job chaining. We call this complex job chaining as pipelines. In Jenkins server, there is one plugin called workflow. By using this workflow plugin, we can create advanced pipelines. And we can create these pipelines by using scripting language called Groovy. And by using these pipelines, you can see each and every step clearly. And by seeing each and every step clearly, you can clearly understand how work is going on. Guys, whenever any developer create project, he will place that project in GitHub. Along with this project, he will create one Jenkins file. And this Jenkins file is written by using Groovy script. I written script. That script contains total 4 stages. One is build stage, next one is test stage, and third stage is downloading artifact, and stage 4 is placing that artifact in server. So I created Jenkins file in order to perform these 4 stages, and this code is written by using Groovy script. Now what I will do is, I will connect this GitHub with Jenkins server. So immediately whenever I place project, automatically Jenkins will perform these 4 operations. And clearly you can see each stage, whether it is successful or not. For example, let us say testing is unsuccessful, then automatically it will stop here. So job chaining is nothing but connecting multiple jobs. So only if one job is successful, then it will go to next job. So if all stages are successful, then my build process is successful. Next I will explain what are build servers and infrastructure as a code. Guys, in DevOps, even if you want to configure your server and if you want to manage your server, even for that operations you need to write code. So in order to create softwares you need to write code, and similarly in order to manage and configure your servers you need to write code. So when we talk about DevOps, you can manage our servers and setups using code, same like writing code to create software. Guys, there are some problems with Jenkins server, and that first one is Jenkins interface. Guys, if you want to perform any operation in Jenkins server, you can perform operations in two ways. First one is by writing script, or else you can also use web interfaces in order to perform operations. There is one advantage of using web interface, that is, there is no need of having any programming knowledge. But this web interface will not provide complete features. If you want to use Jenkins server perfectly, if you want to utilize all features of Jenkins server, then definitely you must have coding knowledge. Jenkins uses code files to set up tasks, but most people use Jenkins web interface to make changes. One good side of using web interface is there is no need of having any programming knowledge, and one bad side is if you use web interface, you cannot utilize complete features of Jenkins server. Guys, for example, let us say I written code in order to set up my server for a particular project. So next time when you are developing another project, you can utilize code which is written before. But if you use web interface, you cannot perform code reusability. You need to perform each and every step again. So this is one of the main drawback of Jenkins server. Instead of using Jenkins, you can also use GitLab. Even by using GitLab, you can perform build process. Whereas in Jenkins, you need to write complete code. But whereas in GitLab, there is no need of writing code. Already some predefined code files are present in GitLab. Directly you can use that code files in order to perform build operation. So if you don't want to use all features of Jenkins, then directly you can use GitLab. GitLab is very simple and friendly to use. And last topic is building by dependency order. When building software, some parts need to be built before other parts because they depend on each other. And you can do it by using various building tools. I'll give an example. Let us say total there are 3 files. One is file A, next one is file B, and next one is file C. For example, let us say this file A depends on file B and file C. So at that time, at first you need to build this B and C. So only after building file B and file C, you need to go to file A. Because this A depends on B and C. At first you need to compile file B and next you need to compile file C. And by using make tool, you can set this order. You can set order like which file need to be built first. For example, by using make tool, I will set order like at first I need to build file B, next file C. After building file B and file C, I need to build file A. And even by using tools like Maven and Gradle, you can set build order. Maven uses one build graph. That graph name is reactor. By using this reactor, Maven will manage order. And even Gradle also use build graph in order to set up order. Even in Jenkins server, you can install reactor plugin and the Jenkins server will show build order for Maven projects. For example, let us say your project contains 2 parts of code. For example, let us say one is part A and next one is part B. So at first you need to compile part A and next you need to compile part B. After compiling part A and part B, you need to combine these both codes and again you need to perform testing on that code. After testing is successful, artifact will be generated. So directly you can place this artifact in server. Next I will explain what are build phases. Guys, Maven is build tool. By using this tool we can perform 3 basic operations. They are, first one is building. Building is nothing but compiling code. Next one is testing. Testing is performed on code in order to catch various kinds of errors. And third phase is deployment phase. After successfully compiling and testing code, we need to place that code in server. So placing our code in server is known as deployment. So Maven tool will perform these 3 basic operations. Guys, whatever project you take, definitely we need to perform these 3 operations. Guys, let us say for example I am developing one project. For example, I want to skip this test phase. Just I want to perform only build and deployment. But you cannot do that because these 3 phases are mandatory in Maven. In Maven, whatever project you take, definitely you need to follow these 3 basic operations. And each and every operation is performed in step-by-step manner. Maven is a build tool that makes sure everyone follows same steps when building software. This is helpful for big companies because they don't need to create their own rules for building projects. Guys, whatever project you take, you need to follow 3 rules in Maven. First one is building, next one is testing, and next one is deployment. So there is no need for companies to create separate rules. Maven very strictly follows order of steps like building, testing, and deployment, whereas other tools like and give more freedom, but it can lead to disorganized build. Guys, for example, if you consider Maven, Maven strictly follows 3 steps. They are building, testing, and deployment. Whereas if you consider tool like Ant, in Ant we can skip testing. It will not follow rules strictly. If you skip any of these steps, then software quality will decrease. These are three phases in Maven. They are building, testing and deployment. Guys, Maven will follow order strictly, whereas other tools may skip some steps. If you want to produce high quality software, then testing is very important. A good CI server will catch errors by running automate test. Maven strictly follows all the steps without skipping any of the steps like testing. Next topic is alternative build servers. Guys, Jenkins server is popular build server in order to perform building and testing of software. Guys, not only Jenkins server, there are some other servers available. They are, first one is Travis CI server. This server is popular for open source projects. And next one is BuildBot server. This server is built by using Python programming. And next one is Go server, developed by ThoughtWorks company. And next one is Bamboo server, offered by Atlassian company. And next one is GitLab. This GitLab also contains build server features. Not only these 5, there are so many servers available. Based on your company and based on your need, you can select server. Next topic is collating quality measures. Guys, collating means collecting. We need to collect quality measures. By following these quality measures, we can successfully build software. A build server can help track and improve software quality by providing testing results. As we know, build server will perform testing and then it will provide testing results. Jenkins can run Java unit test and show results directly on the job page. Guys, by using Jenkins, we can test Java projects. After testing, the results are directly displayed in Jenkins page. And not only Jenkins, there are some other tools like Sonar. This Sonar is a tool that provides detailed code quality report. Guys, Sonar will perform testing during build process and then it will display the results on Sonar server. So developers can see detailed report and based on that they can perform improvements on code. Guys, but there is one problem. Whenever you perform Sonar test, then your server will become slow. So it is suggested to perform testing in Sonar server during night time. So using tools like Jenkins and Sonar can help monitoring and improves code quality, but it is suggested to run Sonar at night time or else your build process will become slow. Next I will start unit 5. I will explain each and every topic in detail. First I will explain introduction to testing. If we are going to release our code frequently, we need to be sure it is good in quality. That is why we need automation testing. Guys, normally in DevOps, at first you need to release basic version of software. After releasing basic version of software, then we need to keep on updating same software again and again. And for every update, definitely we need to test that software. So testing software again and again manually is time taking process. So in order to overcome this problem, we need to do automation testing. Automation testing is nothing but whenever you update your software, automatically system will perform testing, which will save our time. Even though automation test is more beneficial for DevOps, manual testing will also be important. Before we can automate test, we need to perform manual test at least once. This ensures everything is functioning correctly. Guys, normally whenever you develop software, at first we need to perform manual testing on the software. If manual testing is working well, then we need to go for automation testing. So even though automation testing is useful, manual testing is also very important. So whenever you develop software, at first we need to perform manual testing. If your software is functioning well, then you need to go for automation testing. Next one is acceptance testing. Guys, after developing complete software, we need to test that software to check whether it is working correctly as per customer expectations or not. If software is working correctly as per customer expectations, then we will accept the software or else we will reject that software. This is known as acceptance testing. Acceptance testing is very hard to automate and normal developers cannot perform acceptance testing. So it is done by separate team called quality assurance team. That is nothing but testing team. If manual testing is done easily, then automated testing can also be done easily. As a developer, if you store test data correctly in database, then testing will give correct results. So QA team will be happy. Guys, QA team is nothing but testing team. Once testing is successful, then automatically we need to place that code in server. So software will be up to date. If you do these two things, then QA team will be happy. We cannot copy large databases for testing because the databases may contain some personal user information. At that time, we need to remove personal data and we need to select only data that is required for testing. And we need to perform testing only on the selected data. Guys, each and every company is different. So one solution will not work for all companies. A good rule to follow is KISS rule, where KISS stands for keep it simple and stupid. That is nothing but in company, you need to make things as simple as possible. If all things are simple, then you can complete work easily. Next topic is automation of testing, pros and cons. Guys, when we talk about automation testing, all people will get excited because automation testing has many benefits. And the first one is, as computer will automatically perform testing, so software quality will be good. We can complete automation testing in short period of time, so we can release software quickly. And third advantage is, automation testing is less boring when compared to manual testing. Because of these three reasons, many people will prefer automation testing. But in many companies who are handling complex projects, they don't do automation testing. In many complex projects, they will do only manual testing. They don't do automation testing. Whenever we develop any software, then definitely we need to perform testing on that software in order to make sure that software works well. And whereas in DevOps, we need to perform continuous delivery. That is nothing but continuously we need to keep on delivering updated version of software. And whereas manual testing will take a lot of time, that is why we need to prefer automation testing. But there are some problems with automation testing. And the first one is, cheap tests have low value. Guys, unit test is nothing but it is small kind of test that will check whether specific part of code is working correctly or not. For example, let us say I developed one website. In that website, I want to check whether the title is NS lectures or not. This is one of the example of unit test. Unit test is also one kind of automated test which is very cheap. But many companies will not perform unit test. They will only perform manual testing because they will think that manual testing finds more bugs. So many companies will skip unit tests. Second one is difficult to test environments. Testing is very easy, but creating setup for testing is very tough. If you want to create systems for testing, then you need to purchase high hardware for the system and you need to select people in order to perform testing. That is nothing but you need to hire testing team, and in order to perform testing, you need to purchase licensed softwares, which is costly. So testing is very easy, but creating system setups for testing is very tough. And third one is constant changes in software. Whenever developer updates software, then immediately we need to perform testing. So this is extra work for automation test. And fourth one is hard to write good test code. Guys, writing good automated test code is very difficult. Guys, in DevOps, if you want to perform automation testing, then you need to write code. It is very tough. But if you know how automation testing works, then it is very easy to write code. So if you have good knowledge on automation testing, then you can easily write code and you can easily catch errors. Next I will explain Selenium introduction and futures. Guys, Selenium is one of the famous open source testing software. By using this software, we can test websites. And the Selenium software was developed by Jason Huggins in the year 2004. These are some of the features of Selenium, and the first one is automated testing. Guys, by using Selenium, we can test websites. For example, let us say I developed one website. Now I want to test that website. So for that purpose, I need to write script. Whenever I write script and execute the script, automatically testing will be performed on the website. So Selenium allows you to write scripts that can perform tasks on a website, such as clicking buttons, filling forms, or checking if certain text is visible. This saves our time because there is no need of doing it manually. And second feature of Selenium is cross-browser testing. Guys, Selenium will work in any web browsers like Firefox, Google Chrome, Safari, etc. So you can test your websites on any browsers like Firefox, Google Chrome, Safari, etc. And third feature is support multiple languages. Guys, in order to test websites, at first you need to write script. And you can write this script in any programming language like Java, Python, C#, JavaScript, etc. So in Selenium, you can use different programming languages in order to write script. So any developer can easily use Selenium. And fourth feature is open source and support multiple operating systems. Guys, you can download Selenium software with free of cost in the internet. So many companies and developers are using Selenium, and you can use this Selenium in any operating systems like Windows, Linux, etc. Guys, if you want to perform testing using Selenium, at first you need to install one special driver in your browser. After installing special driver in your browser, you need to open Selenium software, and then you need to write script in order to test your website. And whenever you execute the script, automatically commands are forwarded to the driver which is installed in your browser, and then testing is performed on your website. Guys, by using Selenium, you can perform parallel testing That is nothing but you can test multiple websites at a time. Guys, I will give an example. For example, I developed a website. Now I want to check whether my website title is NS lectures or not. For that purpose, I will open Selenium software and then I will write script. By using any programming language like Python, Java or C#, we can write script. Whenever I execute the script, then automatically my special driver, which is installed in browser, will check whether my title is NS lectures or not. Guys, in DevOps, you can integrate Selenium with some other tools like Jenkins, Docker, etc. so that we can achieve continuous testing. So Selenium automate repetitive tasks and save time. So developers can test websites on different browsers because Selenium will support different browsers. Next I will explain JavaScript testing. Today, many software applications or services that people use have web interfaces, which means these applications are used through web browsers like Chrome or Firefox. Guys, normally any application is connected to web interface. For example, if you consider Amazon app depends on web interface. Whenever you install Amazon app and open that app, automatically that app is connected to web interface. And similarly, Flipkart also depends on web interface. So almost nowadays each and every application depends on web interface. If you want to connect your application with web interface and if you want to run that web interface, you need to write JavaScript. So you can run web interfaces using JavaScript. So definitely after writing JavaScript, definitely you must do testing on JavaScript. And in order to test JavaScript, there are various kinds of tools available. And the first one is Karma tool. By using this Karma tool, you can perform unit test on JavaScript, where unit test is nothing but it will check small portion of code and it will check whether it is working correctly or not. And second tool is Jasmine tool. This Jasmine tool will check how software behaves in different situations. For example, if 1000 people is accessing, how software behave. If only one person is accessing, how software will behave. It is same like checking if a car drives smoothly on different roads. And third tool is Protector. Guys, by using Protector tool, we can create web applications and as well as we can test that web applications. And by using Protector, we can test applications that are built with AngularJS. So main purpose of Protector is to test applications that are built with AngularJS. Normally you can also use Selenium in order to perform testing on web applications. But Protector is better to test AngularJS applications. This Protector clearly understands AngularJS. So testing will also be very easy. By using tools like Karma, Jasmine and Protector, we can test applications that are built with AngularJS. And we can check whether application is working correctly or not. So this kind of testing is very important in today's software development. Next I will explain testing backend integration points. Guys, backend testing is like checking the parts of a machine that you can't see. When you use a website or app, the front end is what you interact with, like text, button, image, etc. And whereas backend is everything behind the scene that makes front end works, like databases, servers, applications, etc. Guys, I will give an example so that you can clearly understand this definition. For example, let us consider Facebook app or website. Whenever you open Facebook app or website, you can see Facebook image and you can see username, password and login button. So whatever you see, we call it as front end. Here I can see Facebook image, username, password and login button. So we call it as front end. Whenever I enter username, password and then click on login button, automatically I can log in into Facebook account. How it happened? This is because of backend. In backend, I return code. In front end, whenever I click on login button, automatically my backend code will work. Automatically this code will connect to my Facebook server and then this code will verify whether my username and password is correct or not. For example, I want to upload one image in Facebook. So whenever I click on upload button, automatically in backend my code will work and then this image will be stored in Facebook database. So front end is nothing but whatever you see, we call it as front end. And in order to make this front end work, you need to write code in backend. Whenever you write code in backend, this code is connected to Facebook server, databases, etc. So testing backend code that is connected to servers, databases, applications, etc. is known as backend testing. So backend testing is like checking the parts of your machine that you can't see. When you use website or app, the front end is what you interact with, like text, button, image, etc. And the backend is everything behind the scene that makes front end work. Example, databases, servers, applications, etc. Backend test is nothing but checking hidden parts of code, like databases, servers, APIs, etc. So backend testing ensures that all the hidden parts are working correctly, storing data properly, and communicating with each other without any errors. It involves checking databases, servers, APIs to make sure everything functions correctly. By using SOAP method and REST method, we can automate backend testing, where SOAP stands for Simple Object Access Protocol and whereas REST stands for Representation State Transfer. By using these two methods, we can automate backend testing. And these two methods are mainly used to automate backend testing on websites and APIs. Guys, API stands for Application Programming Interface. This is nothing but code. The code that we write in order to connect front-end and backend is known as Application Programming Interface. And there is one tool called SOAP UI tool. By using this tool, we can write and run backend testing. We can run tests step by step and it is very easy to use. These are benefits of SOAP UI, and the first one is easy for testers. It is easy to write and run testing. And second advantage is good for developers. Guys, in order to perform testing, there is no need of developers to open SOAP UI main screen. Directly we can open command prompt and then we can perform testing. And also we can connect SOAP UI with CI/CD process. So automatically in CI/CD process testing will take place. And third one is free version. We can download SOAP UI software with free of cost in internet. Guys, this is how SOAP UI will work. Guys, whenever you open SOAP UI software, on one side you can see all kinds of tests. So by seeing all kinds of tests, so directly you can select whatever the test that you want to perform. Either you can select single test or you can also select multiple tests. And whenever you click on start button, automatically testings will be performed and directly you can see result on other side. Guys, whatever the test that you want to perform, you need to select the test and you need to write the script in XML format. So XML format is very easy to understand. So XML is very easy to read, modify and organize. And anytime you can modify that XML script because XML script is very easy to understand. Next I will explain what is test driven development. Shortly we call it as TDD. Test driven development is a way of developing software where you write tests before you write the actual code. It became popular in 1990s because of extreme programming. Guys, I will give an example so that you can clearly understand what is test driven development. For example, I want to develop software. So at first what I will do? At first I will develop software. After developing software, then I will develop testing code in order to perform testing. But test driven development is completely opposite. At first we need to develop test code in order to perform testing on software. After completely developing test scripts, then you need to start developing your software. So test driven development is nothing but before developing actual software, at first you need to develop test code in order to perform various kinds of testings. And this method is popular because of extreme programming, which was introduced in 1990s. How TDD works? This is first step. Write the test first. At first you need to understand all requirements and features of new software. Then you need to start writing test code that need to be performed on your code. Before developing any software, at first you need to understand features of that software, like how software must look, how software must behave, etc. And then you need to develop test code in order to perform testing on your software. Second one is check the test fails. Initially, I did not write code to develop my software. So whenever I perform testing, my test must fail. This is expected because there is no code to pass your test. Guys, after writing complete test code, now you need to start developing your software. I will not write any code to develop software. Just I will save my file. So whenever I perform testing on my file, automatically my testing will fail because I did not write any code to develop my software. So after writing complete test code, at first you need to perform testing on initial software and you need to check whether your software will fail or not. Definitely your software will fail because I did not written any code. And third step is write the code. There is no need of developing complete software. Just you need to develop software with only basic features and then you need to perform testing on your software. So here your software must pass. And fourth one is run all tests. Guys, after developing complete software, you need to perform various kinds of testings on the software. If all kinds of testings are passed, then your testing is successful. And fifth step is improve the code. We also call this step as refactoring. In this step, we will arrange code in proper format and also we will remove unnecessary files in the software. So TDD helps you to understand what the software should do before starting the code. It also creates various kinds of testings to make sure everything works correctly. And this test driven development is very much useful in continuous integration and continuous deployment because frequently we will keep on releasing new version of software. At that time this method is useful. Next I will explain what is REPL driven development. Guys, REPL stands for read, eval, print loop. This REPL is software. By using this software you can write and test your code using programming languages like Lisp, Python, Ruby, JavaScript. In any of this programming language you can write code in order to perform testing. In this software you can write code, immediately run and test it. Guys, by using this software you can write code in order to perform testing. Immediately you can execute the testing code and you can see results. So this software allows quick testing and feedback. Guys, this is how REPL works. And the first one is write small function. For example, let us say I want to develop College website. So at first I will create one simple function in order to create user login form in that College website. So at first I will create simple function in order to create login form in that website. And this function must be independent. And this function must not depend on any part of the code. This function must be independent. And second step is immediate testing. After writing specific part of code, immediately open REPL software and then you need to perform testing on that function. And you can write code in any programming language like Python, Ruby, JavaScript, etc. And immediately you can see results. So if there is any problem with that code, you can easily fix it. This is how REPL works. Guys, this REPL is completely different from test-driven development. Whereas in test-driven development, at first we will write testing code. After writing testing code, we will create software. But whereas in REPL, we will write test code simultaneously. That means we will develop some part of code by creating independent function and then we will perform testing. So this method is very easy for developers. And you can also combine REPL with unit test. That is nothing but you can perform unit test for your independent function. Whereas unit test will check whether certain part of code is working correctly or not. These are benefits of REPL, and the first one is quick feedback. Guys, whenever you develop certain function, immediately you can perform testing and you can see feedback immediately. So if there is any problem, you can easily fix it. And second one is simplicity. As you are not developing complete software at a time, if you develop complete software at a time, then testing is very tough. But here we are developing only some part of code by creating independent function. So which is very easy and simple. And third one is enhanced learning. Guys, there is no need of any complex setup for testing. Directly you can open REPL software and then you can perform testing. As we will learn testing by using various kinds of programming languages like Python, JavaScript, etc. REPL driven development is an effective approach, especially for those new to programming. It allows you to write clear and independent functions and allows for immediate testing. So it is very easy strategy for software development process. Next I will explain what are deployment systems. A deployment system in DevOps is a tool or set of tools that automatically move new software from the developer's computer to the production server. Once the software is placed on the production server, all users can access it. Guys, tool and software both are same. So deployment system is nothing but it is a software. Either it can be single software or multiple softwares. For example, I am developer. I created software in my system. Now what I want to do is, I want to place this software on server. So by using deployment system software, we can place our software on production server. Once if we place our software on production server, all users can access that application. For example, if you consider Facebook, all users can access Facebook application because that Facebook application is present on production server. For example, if you consider Amazon website, all users can access Amazon website because that Amazon website is present on production server. So whenever you place your application on production server, all users can access that application. For example, I am not using deployment system software. If you don't use deployment system software, then we need to place our software manually on production server. Placing our software manually on production server is very tough. It may cause errors and it will take a lot of time. That is why we need to use deployment system software in order to place our applications automatically on production server. And there are so many deployment system softwares because placing our software manually on server is very tough. That is why there are so many deployment systems. By using these deployment systems, we can automatically place our application on servers. For example, let us say I created one application. That application contains mainly three parts. One is web server, it will manage website request, and next one is application server, it runs main program, and next one is database server, it stores data. Now what I want to do is, instead of creating three different servers in order to handle my application, what I will do is, I will create only one single server in order to handle all these operations. And that too, whatever the software that I created, I want to update the software only once in a year. So as there is only one single server in order to manage all these operations, and that too I want to update software only once in a year, so placing our software manually on server is easy. But still we don't place our software manually on server because manual work is boring and manual work can lead to mistakes. That is why we don't place our software manually on server. So we use deployment systems in order to place our software automatically on server. Deployment systems will automatically configure our server based on software and then it will place that software automatically on server. Guys, in real life, in big companies, there are so many servers and applications. So we will use different kinds of methods in order to update servers and applications. We can run our application on physical server, or we can run our application on virtual server, or we can also run our application in a container. If you want to run your application on physical server, then you need to use one type of deployment system software, and if you want to run your application on virtual machine, then you need to use other type of deployment system software. So based on servers, you need to choose deployment system softwares. Guys, deployment system will perform following duties, and the first one is deployment system will place our application automatically on server, and deployment system can automatically update our software, and deployment system can automatically configure our server in order to run our application. These are three important duties that deployment system will follow. Next I will explain what are virtualization stacks. But before that you need to know what is virtualization. Virtualization makes you create virtual computers called virtual machines instead of your real computers. These virtual machines acts like real computers with their own virtual hardware like CPUs and network cards. Guys, I will give an example so that you can clearly understand what is virtualization. For example, I am developer. I developed one software. Now I want to test whether this software is working in Windows operating system, Linux operating system, and as well as Mac operating system. But present I am using only Windows operating system, so I can test my software in Windows. But I don't have Linux operating system and Mac operating system. And purchasing Linux system and Mac system is costly. At the time what we can do is, in our Windows system itself, we need to install virtualization software. And in this virtualization software, we can install Linux operating system and as well as we can install Mac operating system. And also you can assign hardware to operating systems like 1 GB RAM, 500 GB hard disk, etc. And whatever the operating systems that you install in this virtualization software, these operating systems will work same like real systems. So instead of purchasing two different systems, by using virtualization software, we can install various kinds of operating systems in our existing system. Guys, now we call this Linux operating system and Mac operating system as virtual machines because they are created virtually in your existing system. Guys, there are so many virtualization softwares like VMware, VirtualBox, Hyper-V, etc. You can install these softwares and you can use. You can use virtualization to test different types of hardwares on your computer. For example, you can test Android phone on your computer using tool like QEMU to test mobile apps. Guys, in your computer, you can install tool called QEMU. After installing this tool, you can connect Android mobile to your computer and you can test various kinds of mobile apps in this tool. So by using virtualization software, you can also test hardwares like smartphones. This is use of virtualization. Imagine you have a big computer that can run many programs. Virtualization will create separate many computers inside your big computer. If one mini computer has problem or uses much power, it won't affect other many computers. So even if one mini computer don't work properly, it will not affect other many computers. Problem in Linux will not affect Mac. For example, your big computer is powerful with 64 cores, like having 64 small CPUs. You can create virtual machine that uses only 2 cores out of 64 cores. If this virtual machine has issues, only those 2 cores are affected, not the entire big computer. For example, let us say your Windows computer is 64 cores. That is nothing but it is like 64 small CPUs. So out of the 64, I can create Linux operating system only by using 2 cores. So if there is any problem, only 2 cores will be affected out of 64 cores. So entire system will not get affected. Guys, hypervisor is nothing but it is special program. By using this program, we can create and as well as we can manage virtual machines. This hypervisor will share computer resources like CPUs, memories, etc. among various kinds of virtual machines. Guys, there are two types of hypervisors, and the first one is bare metal hypervisor and next one is hosted hypervisor. Guys, bare metal hypervisor runs directly on computer hardware. It does not need any operating system. Example, VMware ESX. This is one of the software. There is no need of installing any operating system. Directly you can connect hardware and you can use. And next one is hosted hypervisors. In this you need operating systems. Example is KVM software, which we will use on Linux. Guys, these are some of the popular virtualization tools. And the first one is VMware. Guys, you can run VMware software on desktops and as well as you can run it in servers. And another software is VMware ESX. You can run this software directly on hardware. There is no need of installing any operating systems. And second one is KVM, where KVM stands for kernel based virtual machine. You can use this software on Linux operating systems. This is free of cost. And next one is Zen. By using this software, you can run various kinds of operating systems for better performance. And last one is VirtualBox. This is software developed by Oracle company. Mainly software developers will use this software in order to test softwares on different operating systems. Guys, there is no need of writing any code in order to use virtual machines because you can automate virtual machines with APIs. By using APIs, we can manage virtual machines automatically. One popular tool is LibVirt. And you can connect this tool with various other tools like KVM, Zen, etc. This topic is executing code on the client. Guys, by using some tools, you can directly run commands on the servers and then you can manage servers. For example, I want to check how many files are working in my server. So directly I can use these tools and I can run commands on server in order to check how many files are working. Puppet is one of the popular tools used by IT in order to set up and manage servers. And next one is mcollective. You can use this tool along with Puppet tool. By using this tool, you can run commands on multiple servers at a time. So by running single command, you can collect information from all servers. These tools make it easy to run commands on many servers at the same time, which can be useful to perform various kinds of operations. Next I will explain what is Puppet Master and what are Puppet agents. Guys, Puppet is nothing but it is a software. This software is used by many big companies in order to set up servers and in order to update servers. There are two main components in Puppet software, and the first one is Puppet Master and next is Puppet agents. Guys, Puppet Master is nothing but it is a central server. This Puppet Master will send server updates to Puppet agents. And whereas Puppet agents are individual servers that are connected to Puppet Master, so whenever Puppet Master sends updates to Puppet agents, all Puppet agents will install those updates in their servers. Guys, each server runs many softwares. So it is important to keep our server up to date. And we can keep our server up to date by using Puppet software. Guys, this is Puppet architecture. Guys, DevOps engineer will set up updates in Puppet Master. So Puppet Master is main server. And whereas Puppet agents are individual servers, Puppet Master will send server updates to Puppet agents. And all agents will install those updates. And Puppet Master and Puppet agents are connected to each other by using security socket layer. Next I will explain what is Ansible. Ansible is a tool that helps manage and deploy softwares to multiple servers in a simple way. Unlike some other tools, Ansible don't need special software running on each server to manage servers. Instead, Ansible connects to the servers using SSH and runs command to set them. You only need to install Ansible on the main control machine. Guys, Ansible is nothing but it is a software. By using this software, you can place your software on multiple servers at a time. And also you can manage softwares on multiple servers at a time. And there is no need of installing Ansible on each and every server. Just you need to install Ansible software on main server. And by using this main server, you can update software on all servers at a time. Guys, we call each server as node. And these nodes are connected to main server by using SSH. So there is no need of installing Ansible on each and every server. Just you need to install Ansible on main server and you can connect the main servers with remaining servers by using SSH. And you can update and deploy software on multiple servers at a time. These are some of the important points about Ansible. And the first one is no extra software needed. I already said before, there is no need of installing Ansible software on each and every server. Just you need to install Ansible software on main server, and this main server is connected to all other servers using SSH. So next point is Ansible uses SSH. There is no need of installing Ansible software on each and every server, but you need to install Python programming on each and every server, and any version of Python is okay, and speed of Ansible software is less when compared to all other softwares. This is how Ansible works. Ansible uses special files called playbooks to define what you want to do on servers. These playbooks are written in a straightforward language called YAML. Guys, in main server, you need to create special files called playbooks in order to perform operations on all servers. And we are creating these playbooks using programming language called YAML. For example, let us say, I want to check how many servers are working. So for that purpose, I will create one playbook using YAML language, and this playbook is executed in all servers, so I can clearly check how many servers are working. Next, I will explain what is Chef. Guys, Chef is same like Ansible. By using this Chef software, we can manage and deploy softwares on multiple servers. That is nothing but we can place software on multiple servers at a time, and as well as we can perform various operations on servers at a time, like we can update software, modify software, etc. In Chef software, you need to use Ruby programming language in order to set up servers. This is how Chef works. You need to know what are recipes and cookbooks. Guys, in Chef, you need to create files in order to perform various operations on servers, and we call these files as recipes. And if you place all these files in one single folder, then we call it as cookbook. So Chef uses files called recipes to define what should be installed and configured on your servers. A collection of recipes is called cookbook. Next, you need to know what is Chef server. Guys, Chef server is central server. In this central server, we will place complete configuration data, and as well as we will place various kinds of cookbooks. And we will store all these files in organized format. Guys, nodes are nothing but individual servers other than main server. Next, what is Chef client? Guys, Chef client is nothing but it is a program. Whenever you execute this program, you can check which server need to be configured. And by using Chef software, we can automate server setups, and also we can verify all servers are configured correctly or not. And this complete work is automated. There is no need of doing it manually. Guys, this is Chef architecture. Workstation is nothing but it is a computer. In this workstation, administrators will create cookbooks, where cookbooks contain various kinds of files that will perform various operations on servers, and they will upload that cookbooks on Chef server. So Chef server is nothing but it is a place where all kinds of cookbooks and as well as configuration data is stored in organized format. So from workstation, whenever cookbooks are uploaded in Chef server, automatically that code is executed. Operations are performed on nodes. So nodes are individual servers that are managed by Chef server, and each node runs Chef client for updates. Next, I will explain what is Salt Stack. Guys, Salt Stack is a software. By using this software, we can manage and as well as we can control multiple servers at a time. There will be one central server called Salt Master. This Salt Master will send instructions in order to perform various operations on remaining servers. We call all remaining individual servers as Salt Minions. In order to perform operations on Salt Minions, we will send instructions in the form of files. We call these files as state files. By using the software, we can automate server setups and configurations, and as well as we can manage servers, and we can perform these operations at a time to all servers.